Verás. Verano. Vale, bueno.
Te va bien el coche, ¿no?
Sí, estoy probando porque el audio no lo consigo. O sea, lo que estoy diciendo yo ahora no lo oigo en el vídeo, por eso estoy mirando a ver. Vale, no, eso es lo que vale entonces. Vale, ya está. O sea, va con un efecto retardado, pero.
Con delay, ¿no? Va con algo de delay.
Sí, pero se oye bien.
Vale. ¿Qué? ¿Tú eres la moderator?
Sí, aquí sí.
Are you the moderator?
Hello again, Casey. Casey, yeah.
No, no sé por qué desde aquí, no sé cómo la llaman.
Katie, will you tell me when I start?
Yeah, I'll come up, yeah. And Martha needs to start the streaming and then I'll come up and introduce you. We need to wait a couple more minutes because I expect there will be more people.
Sorry?
We need to wait until the time because I expect there will be more people too.
Ah, yeah.
Oh no. Okay, so I think this time we can get started. I'll just open your presentation for you. Okay, so welcome everyone to the first kick-off session in this room for IMBRSea 2023 Annual Symposium here in Oviedo. I'm delighted to welcome 3 speakers in this session. Each speaker will have 15 minutes to present and 15 minutes for questions and answers afterwards. We have our jury members here. I'll be moderating and Martha will be helping with the IT systems. So our first speaker is Jun, and Jun is going to speak about modelling biogeochemical cycles in the ocean. So over to you.
So I can start?
Yeah.
Yeah. So hi everybody, my name is Jun, and today I will be presenting the preliminary result of my unfinished master thesis about modeling dissolved oxygen in the Pacific Ocean. So the oxygen in the ocean goes through different processes. One of them is the biological processes that can either consume or produce oxygen, like respiration, photosynthesis, remineralization, and so on. We have also the air-sea exchange, where the oxygen in the atmosphere dissolves in the surface of the ocean, and it's a process that depends on the temperature. And we also have the advection and the diffusion that allow the oxygen to be transported throughout the ocean. And the latest process, the the transport is really important, especially in the Pacific Ocean, as it is the main input of the oxygen in the Pacific Ocean. So because of its cold temperature, the Southern Ocean has a lot of oxygen. Because of its cold temperature, it can store more oxygen, and there's more oxygen that can be dissolved in it. And through the Antarctic circumpolar current, which is the current represented by the arrow, it supplies the Pacific via the current. So the goal of my master thesis was to compute the biogeochemistry of the Pacific Ocean with the help of a biogeochemical model coupled with a physical model, and then to conduct some sensitivity analysis of the oxygen on different parameters. We tested 3 parameters: the numerical scheme used for the physical model, the nitrogen fixation by the bacteria, the azeotroph, and the supply of nitrogen by the atmosphere. And for this presentation, I will be showing the result of the latest one, the nitrogen deposition. So the physical model used for this thesis is the NEMO model. So basically what it does is that it simulates the dynamic of the ocean, the current, the physical property of the ocean, and other property. But we are interested in the dynamic and some of the physical property, as it is where it is coupled with the biogeochemical model. So with the current, it can compute the advection and the diffusion that all the elements, like all the tracers of the model go through. And the temperature is also important because, as I said before, there's the air-sea exchange of the oxygen that impact the supply of the oxygen to the ocean. So the temperature will determine how much oxygen is input in the Southern Ocean. And for the simulation, the physical model was forced by the atmospherical data of the 1960 to 2000 period, climatology data. So at the end, we'll have a climatology data of this period. So the simulation was done on the whole global ocean, but the analysis was only done on the Pacific Ocean, this area. So to describe the grid, it's the resolution. The horizontal resolution is 2 degrees by 2 degrees, but it has with a local refinement in the tropics and the equator, and also in the other area, but we are not interested in those areas. And there is 31 vertical level that go from the surface to around 5,000, and also with a high resolution in the upper layer. For the biogeochemical model, I use the Pisces model. So it simply simulates the biogeochemical cycle of the carbon and the main nutrients of the ocean, like the nitrate, phosphate, and so on. And also simulate the lower trophic level of the ocean, the phytoplankton, and the biogenic matter. And they are all linked by a Redfield ratio and other process. And so we are testing so what we'll see, and what I did, one of the analysis I did was to test the nitrogen fixation because it's depend on the species. And the input of the nitrogen by the atmosphere. We also have the input by the river, but I just took the default value that was given with that was provided with the model. So at first I did a run with the default value given provided with the model, just to see the performance of the model. The result was compared to data from World Ocean Atlas. And so this is a Taylor diagram. So basically it shows us the correlation with this axis, the standard deviation compared to the standard deviation of the data that we want to compare, which is this axis, and the square root differences which are represented by this axe. So basically the closer it is to the reference point, the better performance it is, and the furthest the waistband. And so for the oxygen, we can see that the correlation is quite good with around 0.95. But the standard deviation and the differences are not, there's not big differences, but there's still a significant differences. And to see where is the main differences, we can see this is a view of the north-south section of the central Pacific Ocean, the central section of the Pacific Ocean. And so this is temperature, oxygen, and salinity. So we can see that the dispersion of the oxygen is quite similar, but it's more like the scale that's quite different. And to see where does this difference come from, as I said back, the supply of the oxygen mainly comes from the transport from the Southern Ocean, which depends on the temperature. So if we zoom at this area, we can, sorry for the scale, yeah, it's not the same scale, but we can still see that the Pisces model underestimates the temperature. It's almost the double, and so this is why the oxygen is much higher. You can also see here how much is higher in the model, because we have a higher input of oxygen from the atmosphere. So now the sensitive analysis I did was to test the impact of the nitrogen deposition by the atmosphere. So I took two different deposition, one from the paper. This is the one from Duce, and this is the one provided by the model by default. And this is deposition calculated by Lamarck and from another paper. And globally, the one from Duce is 80% higher than Lamarck. So this is the center one is this plot is the concentration of nitrate without deposition, with the deposition from Duce, and there is the deposition from Lamarck. Sorry, we can't see it well, but this is the concentration, and here is the percentage of augmentation or diminution. And as you can see, and as I expected, the more nitrate comes, the higher the increase, but the increase happens principally in the area where there is low concentration of nitrate. This is the same graph, but with the primary production, and we can see that it follows a similar pattern. And this was only for the upper layer, for the first 100 meters, because there was no significant change in the deeper layer for those two elements. And here is for the oxygen. So this is the oxygen level, and this is the differences. And we can't see well, but globally the oxygen decrease. So this is for the upper layer. And sorry, this is the same, but so I made a mistake. But basically, this is for the intermediate layer, and there is a higher differences in the intermediate layer for the oxygen, and this can be explained by this little draw. So the higher the primary production is, we have an increase of organic matter, and those organic matter will sink to the deeper layer, and at that surface, at that depth, those organic matter will be remineralized, which will consume oxygen, so we'll have a decrease of oxygen in the upwell layer, which explains why there's decrease of oxygen with higher primary production. So to conclude with the climate change and anthropological activity, we expect to have an increase of the temperature in the Southern Ocean, and also an increase of atmospherical nitrogen deposition. We can conclude that we will expect a decrease of dissolved oxygen due to those two elements, and this can have consequences on marine life, like nutrient cycle, as it is really important for those two elements. And for future research, we can first correct the model by have a better estimation of the temperature. There is several parameters that I discovered that was not really well calibrated, so we can also calibrate them better for future research. And for additional research, we can test the effect of the current with past, present, and future current as before. It is one of the main components for the supply of oxygen, and we know that the current velocity are decreasing because of climate change. We also can see the sensitivity. We can also test the sensitivity analysis on the numerical scheme as it impacts the final output. And we can also try to analyze what is the impact of the oxygen on the cycling of the other nutrient to see how much it can impact it. And to finish, one of the most important, since the Pacific Ocean has the two biggest oxygen minimum zone, we can also try to see how those effects can impact like if it will decrease or increase the size of the oxygen minimum zone. Thank you for listening.
Thanks a lot, John. Well done. Any questions from the audience? Yeah, one here.
What was the time scale you used for your model again? Like how long? Was it?
So this is a climatology simulation. So we got the mean of this period like for 1 year. So this was from another paper. So I have the annual mean of this period, and I run it with the model, and we run it until we have a stable state for each nutrient.
And what was that time? Like you
That time was like 2,000 years of simulation, to be sure that every nutrient was stable throughout the time. Yes.
And I was just curious about the smaller scale in the tropics and the equator.
Yes.
Is there because there's a lot more biological processes and so on going on?
Yes. I mean, I didn't choose the grid, but it's because we have, like with the upwelling and the temperature and those kind of process, it's important to have a bigger resolution. Then here it's quite homogeneous, so we don't really need to be really precise. This can be seen here. We also have a refinement here and like those little area, because the same like the processes are happening in smaller scale. This one.
Okay.
See.
You also said that you picked the nitrogen thing because it's associated with species.
This one?
Yeah.
Yes.
Did you find anything like?
It's what I'm doing. I have some results that I put here in the annex, but I didn't analyze it yet. But I mean, I think it's similar to here. So more fixation, more nitrate, so more primary production. So it's the same pattern. But I didn't have time to really look at it yet. But we have quite a big differences. But also because I choose big differences between the different values.
Questions from Peter?
So our thing.
Yeah.
Okay, so thank you for the presentation. Just the first question, you mentioned that this is partial work, so not finished yet.
Yes.
Understood. So what is the reason? Technical problems or?
So the plan A was so my supervisor create a model,
Yeah.
which is called Bambi, and it was a model to also simulate the biogeochemical, but it was only run in the Black Sea. And Black Sea is interesting because it has the oxygen content is quite low. And so the plan A was to implement this model, but in the Pacific Ocean, because also of the oxygen minimum zone, it was interesting. Because that model is performed quite well in anoxic zone. But we had some technical numerical problem. We had a numerical stability problem. I don't know why, but after like 20 years of simulation, we just have a huge increase of nitrate. It was really random, and so we tried to. I tried to figure out, but it takes time because it's more like computer stuff, and I'm not really specialized in that. And yeah, that's why I switched. I didn't switch to. I mean, that's why I did the rest of my research on this model, because the format of the model is similar. The other model is also coupled with the Nemo one, and all the parameter, like how to put them, like the format, the input are really similar. So I first exercising with this model to be able to switch on to the other one, but since the other one had a trouble that we didn't solve yet, I did my analysis on this model. Because also all the script to analyze was already done, so I just ran the analysis with the viscous model to put it here. And we'll see if we manage to solve the problem. Because if you solve it, we can just run the model and with the output just put them in the script, and it will be quite quick. And the analysis too, but yeah, that's why.
So in this way, how flexible? I mean, that you mentioned that there are other kind of parameters that should be considered also. So this model is appropriate just to introduce all these additional parameters for further work in the future, or?
Sorry?
So you mentioned that you focus a lot on let's say nitrogen,
yes,
and so on. And at the end, you mentioned some kind of other, let's say, parameters like currents and so on, that nutrients that can be incorporated, even the effects of microbiota. So this model is quite flexible, that can incorporate that, or maybe it's just any kind of models that need to complement this.
No, it's quite flexible. It's quite easy to change. If we want to change some parameters, just on the script we just change number. But to implement like a new equation, it's quite complicated because for like somebody who doesn't really know how to code, because it's code in Fortran. So it's quite, it's not something that is common for everybody. But if you have an informatician who is quite good at this, I think it's quite easy to implement it. I didn't implement, but I changed a bit the model to have some more output. So I think it's flexible if you know how to change the Fortran code. But yeah.
Okay. So first of all, congrats. I think you are here, so well done. It's not easy to present preliminary data, so well done. I think you did a huge effort, and also I like that you have some supplementary slides to show that this is really work in progress. So well done, congrats. So first of all, I'm not an expert on these kind of topics, but in any case, I have some. So you clearly show us that these are preliminary results, so it's fine. So for this modeling, you are taking like average per year. Let's say for this period from 1960 to 2000, you are taking the average of certain parameters. It's not that you're doing within a year comparison, no.
No, it's average.
Average. Are you planning at some point to do this? I mean, to also include within the year, because the condition, the oxygen condition, I guess it's changing.
Yeah, it's changed.
Depending the time of the season, let's say, no? Or,
Yes.
or
I mean,
you're more like interested in more like in the general part?
yeah, I think I won't have time to do to try. I mean, I would like to try new, as I said, like past, future, and present condition of the current.
Okay.
But it's so this is offline, which means we just, as I said, we take the mean of that period,
Yeah.
and then we run it, and it takes quite a lot of time to run. So I think if I have more time and I have the data, why not? It can be really interesting to see it. But for this experiment, it's just a general overview.
Yeah, okay. So the other thing I was having in mind, like, you know, when you're doing some modeling, it's always great to have some sort of case study or some sort of expected results.
Yes.
Like, okay, I know that I should pick up, if my model is correct, I should pick up this and this and that.
Yes.
Do you have that those sort of controls? Or can you imagine some sort of control that you can have or think about it in some period of time, in some particular region of your study area, that you say, okay, if my model is working, I should pick up this because this was well described in that paper and that paper and that paper. Do you have something like that?
Yes.
Or have you considered that?
I mean, as I said, the biggest oxygen minimum zone is in the Pacific, and so we are expecting to have the a really low oxygen zone here and here. And for the sensitivity analysis that I did with the type of deposition, I mean, it was quite obvious that the more nitrogen input, the more nitrate we have. So, and there was a paper also describing this phenomenon, like the same trend. So, and it also had the same trend for the primary production. So this was something that I was expecting to have.
Okay, if I were you, I would present also like that. Like, okay, we found this, and it's expected since, you know, it's well reported in this particular region and with many measurement and not only modeling but just measurement in the field or whatever. So it's, I'm just talking for the format presentation that you might have that's into account, but it's great. Also, because for what you just mentioned, it's not an easy task, this modeling.
Yeah.
So which was your contribution to this? Which was your involvement on that, on modeling and changing parameters, or was like some trial and error, was some advice from your supervisor, which was your degree of involvement on that?
So as I said, we first tried the first model of my supervisor, and I think for this one I contributed in the way that I found there was a lot of mistake. So like, we did one run, there's a mistake, we fix it. Another run, I found a mistake, we fix it. The fixation of the mistake was not really in my range because it's like computer and numerical scheme stuff, and we were doing biology, so it wasn't. I mean, I tried to help, but she was the one. So I think my involvement is more in this, like, we ran the model and we found that there was an error. So that's how I contribute to this project. And so this model is a European thingy. So can I draw?
Yeah,
So,
let's jump here, yeah.
so how it's worked is that we do like 50 years of simulation. We do 50 years of simulation, and then with the last value, we do another 50 years, and so on and so on and so on. And I don't know why we may think that there's a problem with the transition between the two. So this is also something I didn't mention because it was just something that maybe it's not true, maybe it is true. So maybe it is, but it's not sure yet. I still have to see the results.
Okay, so from the side is great. So once again, congrats and well done. Okay.
Yeah. I think that's all for the questions. Oh, there's still questions. sorry. Thank
No
you,
problem.
Fernando.
Well, good morning, Luna. Thank you very much for this fantastic presentation. I worked for a few years in a biochemical modeling group, and I'm really, perhaps my first question or comment is that how can you be so brave of trying to do a job of this nature, or taking a job of this nature for such a short period of time? Because tuning these models and putting them at work, it's actually a huge task. And the other day I was attending an NSF meeting. They were discussing about the future of the ocean and the implementation of nature-based solutions. Lynn Russell, who was the leader of that task, was commenting that there are a few thousand oceanographers in the world, and less than 1,000 who are able to run and work with these kind of models. I don't know what you are planning to do, but with all that kind of developments in the horizon, like the digital twins and these kind of things that are and all those kind of huge issues that as a society we are facing. My first comment will be congratulations, and if you like it and if you enjoy this task, keep on. Okay? It's a complicated thing.
Yeah, I like it.
Okay. I'm not paid to do this kind of comments or questions, okay? So I would just do a few comments. The first one is, why 2 degrees for the resolution of your model? And I understand that you're running a global model covered by a climatological forcing, atmospheric climatological forcing, and that you are making a comparison for the 31 levels simultaneously for oxygen in that target area that for some reason excludes part of the Western Pacific.
Yes.
I don't know why, but if you want to comment. So that's the choice. Why that design? Why that resolution? And what do you think about it? If you were able to do something or to repeat something, will you modify something of that design?
So the 2 degrees, because as you say, it takes time to do this kind of simulation. So the bigger the degree, the less data we'll have. So it was more to so I have the habit of not waiting 1 week to have results, because I think there's a 0.5 resolution also in the whole ocean, and there's a 1 degree. So there's a different choice. We took 2 degree because so it's faster, just because my thesis is a short period to just have time to be familiar with the model. And then the area was so I was just mostly trying to see the performance in the Pacific Ocean was because of the oxygen minimum zone, and I didn't take this area. I think it's because I just cut the model like the grid just to have this area. I think it was just a mistake from me. I didn't really take into account this. I also thought that maybe this little area was a bit not. I mean, we have upwelling here, so that can be interesting, but I was just more focused on the global part of the Pacific Ocean. That's why. Also, I didn't really pay attention of taking this little.
Very quick question.
Yes, a really quick question. Yes. So you are comparing with the World Ocean Atlas.
Yes.
The results. Sometimes these models have huge biases in terms of the geographical location and extent of features. But that does not impede them or prevent that then provide reliable concentrations and things like that. Have you thought about any kind of solution for that, or what was your approach to cope with this kind of?
For the run I did. So this can be interesting by trying the different numerical scheme, as I said before. There's some numerical schemes that are better in big resolution, and some other numerical scheme that's better in finer resolution. So this is an analysis that I have done, but I don't have the result here, I'm sorry. So testing the different, I test 2 different numerical schemes, the FCT and the muscle. I don't know if you know Yeah, but
I'm not a model, okay?
so anyway, there's some paper saying that some perform better in one in a bigger mesh and other in a finer mesh. So I think that can be interesting to say which one we should choose and if it does a big difference, if it make a big difference or not between those in the choice of numerical scheme.
Thank you.
Great. Thanks very much, John. Well done. Oh, fair.
That's fine. Is there a clicker
Yeah.
just on here?
Yeah, on the keyboard. There.
Okay.
Okay, so our next speaker is Stephanie Meyer, going to talk to us about fish and fisheries in the Black Sea. So over to you, Stephanie. Good luck.
Hi, so yeah, I'm Stephanie Mayer, and I'm presenting you my master thesis, linking patterns in phylogeny, traits, abiotic variables, and space. And it used to be called Black Sea Fisheries, but it was changed to Black Sea Fishes because it was supposed to be based on fisheries data, which I never received, and then we had to use other data sources, which also caused some delays, so I also haven't officially submitted my thesis. So this is a contribution to the Bridge Black Sea project, which aims to enhance science-based policy in the region. So the Black Sea is a very unique and fragile marine ecosystem. It's the largest body of anaerobic water, and it faces many challenges related to overfishing, pollution, acidification, invasive species, etc. So my contribution to this project is to investigate fish diversity in the Black Sea. To do this, I took a holistic approach. So instead of just looking at taxonomic diversity, so which species are there, I'm also looking at functional diversity, so the functional roles of the species, and phylogenetic diversity, so the evolutionary history of these species. And I'm also looking at, I'm taking a multifaceted approach, so looking at richness, divergence, and regularity. So in terms of functional diversity, functional richness is the amount of functional space that is filled. Functional evenness is how evenly these traits are distributed within the space. And then functional divergence is how these traits are dispersed from in the range towards maximum and minimum range of traits. For phylogenetic diversity, richness is the amount of evolutionary history. Divergence is how closely related are these species within the assemblages, and regularity is the distribution of this evolutionary history. Okay, so the research aims are to identify regions in the Black Sea that either have high or low fish diversity, and then try to understand what the factors are behind this, and also identify species that contribute to these high or low diversity. So the first part of my thesis was to make a functional trait matrix. So from fish base, I extracted biological traits which can be used as proxies for key ecological functions. So for example, for food acquisition, I took trophic level and maximum length. For reproduction, I took reproduction mode, type of fertilization, parental care. For habitat, average depth, depth range, and position in the water column. And for defense against predation, I took body shape. We also needed a set of phylogenetic trees. This was done by Dr. David M., who is a subject matter expert. So he integrated information from the fish tree of life from Rogowski, and also from this other study, which looks at chondrichthyes, and he graphed the missing species onto the backbone of the phylogenetic tree. So then we had a set of phylogenetic trees for all the species in the Black Sea. Yeah. And then the next part was to create the range maps for all the species in the Black Sea, which was originally supposed to be done using fishery data. Instead, we used opus and JBIS occurrences, and then using a function that was made by my promoter, Dr. Camille Bouy, these occurrences were changed into distribution maps, and then which was the distribution was the, yeah. And then these were corrected with for the species with metric range. So for example, for the IMBRSea bream, which is found between 0 and 60 meters, the bathymetry was restricted to that, so then any of the range that was outside of that was removed, which led to a range map which looks something like this. And then we also had other bathymetric corrections to correct for biases. So for example, for pelagic species, the maximum depth was changed to the maximum depth of Black Sea so that they wouldn't be restricted by the bathymetry. But we only had around 40 species that had more than 20 occurrence points on JBIS and OPUS, so I had to find other ways to get data for distribution maps. So I got data from fishery data from Sea Around Us and Fish.j, which is from the Food and Agriculture Organization, and I created a function that made distributions for the species based on the areas that they had been fished. We also used polygons available from the IUCN Red List for certain species, and the FAO also had aquatic species distribution maps available. And then we integrated these maps together. So if there's only one source available, then that map was selected. If either the information was complementary or identical, then the maps were combined. And then I also visually checked them to make sure that there wasn't any maps that gave false information. For example, sometimes the function with buffering led for the distribution to be in a bioregion where it shouldn't be. So in that case, it wasn't included to be integrated together. And that led to a range map that looks like this, which is like the combination of all of those maps together, which gives like a better full picture of where we expect the species to be. And then we finally could do this for 187 of the species out of the 203, and some were excluded because they just weren't supposed to be in the Black Sea, and some just didn't have data. So then we took all of these range maps and we stacked them onto a grid covering the Black Sea at a 0.1 resolution. So this made a community matrix. So we had a present absence community matrix. And then this could be used to look at the taxonomic diversity index. So in my case, it was species richness. So here we have the different bioregions in the Black Sea. We have, which is the exclusive economic zones of the country, with Turkey being separated into Turkey in the Sea of Marmara, the western region of Turkey, the eastern region of Turkey, and then for Ukraine, we also have Ukraine separated in the Black Sea Basin and in the Sea of Azov, and the same for Russia. And then we also wanted to get our functional diversity indices, so this was made with our functional trait matrix, which then we used the Gower distance because we had both continuous and categorical traits, and then we did a PCOA, which was, and the first 5 PC axes were chosen based on the lowest mean deviation, and then those were used to compute the functional diversity indices, and then the phylogenetic trees that we generated were used to compute the phylogenetic diversity indices. And then to decorrelate from species richness, so we could see like what the effect of these functional diversity is regardless of taxonomic diversity, we also standardized them. So we used null models. So we had the SES, which is the standardized effect size of the index, which takes the observed minus the mean of the null model over the standard deviation, which gives SES values greater than, under the assumption of normality, SES values greater than 1.6 meant that higher values than expected by chance, which is overdispersion, and then values lower than minus 1.96 meant low values expected by chance, which is clustering. So here we did non-parametric test to see if the bioregions were significantly different, and they were significantly different, and then we did Dunn's test for multiple comparison to see if they were significantly different between each other. So here we see that the Sea of Marmara is significantly higher in species richness than all the other bioregions, which is evident on the map. We did the same thing for functional diversity. So here we have functional richness for the standardized effect size of functional richness. And we also see that the Sea of Marmara is significantly higher in functional richness than the other bioregions. And then for PD, the standardized effect size of FATES PD for phylogenetic diversity, we also see that the Sea of Marmara has higher, more evolutionary history than the other bioregions. So this helped us identify the Sea of Marmara as a region in the Black Sea that has high taxonomic, functional, and phylogenetic diversity. Then we also computed functionally unique, specialized, and endangered, the FUSE index, and evolutionary distinct and globally endangered, the EDGE index. So what this does is it takes species that are in extreme isolated in trait space, and then also takes their global endangerment, so it considers the IUCN risk category. And then for evolutionary distinct and globally endangered, it takes the evolutionary distinctiveness, so phylogenetically isolated species, and the global endangerment. So here, compared to the other maps, we see that the Sea of Azov was not highlighted at all here, but here it is. And we also note that the angel shark, the European eel, and the spiny butterfly ray are among the top 5 species in both the FUSE and the EDGE index, and these have important habitat in the Sea of Azov. The angel shark is one of the most globally endangered elasmobranches because of its vulnerability to fisheries and low fecundity, slow growth and maturation. We also note that the sturgeons probably play a big role in this because they have also important habitat in the Sea of Azov. Most of them that are included in this study are highlighted in the top 20 for the FUSE and the EDGE index. These are really important in terms of phylogenetic diversity, since they're over 200 million years old. They also can have huge sizes, or they used to a bit more. This is huso, and they're also economically important because they're important for caviar production. So yeah, and then these are the other indices that I computed that I don't really have time to go through, but it's really interesting so I said I looked at multiple facets, so it's interesting to look at the more complex patterns of diversity. So here we can just see that there's an area between all the indices of consistently significant overdispersion, so it's a hotspot that's identified. And then when we look at the phylogenetic diversity, we also see that it's highlighted, and then in that specific hotspot that we identified, we have low PD, high MPD, low VPD, and high MNTD, which are related with areas of low speciation and low extinction. So yeah, we also identify the role of death in this hotspot, as we see when we take the top percent of the functional diversity indices. We see that it's along between 200 and 1,000 meters. This is seen in other studies, which shows that there's overlap between evolutionary distinct and functionally distinct shallow species and deeper species. But we also have to note that this would probably be different in the Black Sea because of the oxygen minimum zone. So all the depth ranges that I took for my species were for fish base, were based on the specific species, but not the species in this area. So we would probably have to look more into what the depth ranges of the species are in the Black Sea to get more robust results. So to conclude, this is a baseline for future biodiversity assessments. So we now have comprehensive range maps for all the species in the Black Sea. So the results are all 100% reproducible from taking the fishery data and turning it into the function. It's all being put on a GitHub page. We have extracted key biological traits which can be used as proxies for ecological functions. We have phylogenetic trees, and now we have a catalog of the different diversity indices. We identified regions of interest, so the Sea of Marmara, the Sea of Azov, and the Ukraine bioregion, which may be highlighted, which diversity may be related to the Danube Delta. And then we also highlighted species of interest, the angel shark, the spiny butterfly ray, the European eel, and sturgeons to look into more when doing analyses for the Black Sea. Okay, thank you.
Great, thanks a lot, Stephanie. So, questions from the audience or the jury members?
Yeah, I had one. So
Oh yeah.
did you expect really the Sea of Marmara to be the interaction with the Med, I suppose, and so on?
So yeah, because it's kind of it's a transitional region between the Mediterranean and the Black Sea. It makes sense that there's higher diversity there, since there's like unique niches to fill functional space, and also unique lineages that kind of mix between the Mediterranean and the Black Sea. But also research actually shows that, like, in reality, this area is really affected by pollution, so it might have lower diversity. So in terms of like the distribution of species, yeah, it is richer, but in terms of like how well it's doing,
Ecosystem health is well.
So yeah, it's more just identifying a region that is important, because also a lot of studies that look at the Black Sea, they don't really consider the Sea of Marmara or the Sea of Azov. A lot of the models don't, but for the JFCM, they do consider it as part of the Black Sea. So
The Sea of Azov is the one in the
in the
right
top.
corner.
But that one's like, it's only 14 meters deep, and it's like not included in any of the models, but it's pretty important for spawning and for feeding.
Okay, so congrats, really nice presentation, and congrats for being here, and clearly you showed us that this preliminary data, so more data are coming, I guess. And also congrats because, I mean, as a species, we have to adapt, and when you don't have the data, you have to adapt and see how you re-ask the question that you want to answer, or keep the same question and see which kind of data you could handle to solve that. So in that sense, congrats again. So just in terms of presentation, I think the introduction of your thesis, it's somehow lacking, no? You didn't show us why your approach is super important. Or I got it, but I think from the presentation point of view, I will increase a little bit more, like some sort of introduction to see the relevance, because it's quite relevant. And one thing that I really like is this holistic approach. I think it's really nice. So in that sense, I was missing that part more, like the introduction of the topic, why they're relevant, why it's important to take this holistic approach and so on.
Yeah.
And so what do you think that are your major limitations in your approach?
The main limitations in my approach, well, first of all, the range maps, I did the best that I can, but a lot of them had contradicting information. So for example, for the angel shark, if you look into studies, some of them have only been like identified in Turkey, but then the range maps for the IUCN is different than the range map for the FAO. So there's like a lot of discrepancies in the map, so that's a big part of it. And then the other thing that I mentioned is really like the depths of the species, since there's an anoxic zone after 200 meters, so we don't really expect fish to be there after. So without the like specific depth ranges for the species in the Black Sea, it's likely to change a lot of things. But I think honestly, compared to the first time that I did these results with the very little data compared to what I did when I like kind of accumulated different sources, the patterns make a lot more sense. And I didn't really have time to go into them, but when you really look into the different indices, you can see more complex patterns, which like bring up interesting things to look into further. Like it doesn't confirm anything, but it just draws a lot of interesting patterns that make sense. So
yeah, because what I was clear saying, I mean, that's why I surprised when I say like 100% reproducibility is like, really?
Yeah.
It's really 100%.
Yeah.
I mean, when what I think, I mean, of course, every single work has limitation, and we have to acknowledge them.
Yeah.
And it's fine. I mean, of course, and when you have an analytic approach, of course, there's some limitation. That's for sure. But then I think that approach has certain, or in some cases, huge dependencies on databases. For example, in terms of phylogenetic information, when you reconstruct a phylogeny, I mean, you're limited to the samples that are already available in the databases, I guess. So the branch depth could change. So, and your indices could change. That's why I think it's with time. I mean, that's when I say 100% reproducibility, what do you mean?
I meant like, so I coded everything in a way that you can just rerun everything and get the same results that I've gotten from all the data sources that I've used. Like everything is completely, like you can download the uncleaned fish stats.j data, and then it gets all processed.
More for
and then and then for the function that makes the distribution maps, you can also just get any of your specific bioregions, and so that's what I mean in 100% reproducible. It's just that it's like very available and open. And for the phylogenetic trees, even though I didn't do them, they were done by an expert, but his code is also available, and he basically regrafted them, but then he also, like, there was in the end 100 phylogenetic trees to make sure to assure for the discrepancies that you're talking about.
Okay, that's once again congrats. I really enjoyed your presentation. Thanks.
Thanks
a lot. Okay.
So we have time maybe for 2 more questions.
One more.
Perfect, one each.
So maybe we could have the first question and then the public, no? Just
Okay, we do like a very very quick question. So very nice work. The thing is that at the end, so you have presented here a lot of indices and so on. And a manager of the region, and you need to tell me, okay, the real situation. So what is your real output? I mean, what is the relevance, and what is the take-home message in order that the manager knows, instead of showing all this data that you have shown, that you need to integrate in one slide the state and say that's the my real output and my real info that you need to know.
But it's like what I said at the beginning, right? So it's like, what are the areas? So the 3 areas that I identified are the Sea of Marmara, and then this hotspot kind of thing. So it's more like my results are the regions that I identified, and then the species associated with those. And then if you kind of go look, I moved them to the end now, but if you look into more specifically between the indices, then you can look into like more patterns. So this is like looking into the geology of the area, and then related to VPD versus VNTD, which shows more like ancient speciation versus recent. So it can kind of, relate it to the geology and relate it to, here you see the ocean circulation. So it just kind of, it's more really describing what is happening in the Black Sea and stuff. It's just more really descriptive and just kind of not really making any strong conclusions, but it's really like a baseline for further investigations. It's just the first time that really the whole entirety of the Black Sea has been looked at in this way for fish. So, I don't know if it makes sense.
So, well, Stephanie, congratulations. Thank you very much for the presentation. I didn't want to lose the opportunity to tell you that.
Yeah.
I really like it to see it, and it brought me to another time and space for myself. I have experienced from first hand the frustration of trying to reconstruct the species distribution maps.
Yeah.
I also like it a lot that you said that you check it every single map.
Yeah.
We are all the time, recently listening about artificial intelligence and things like that, and it's amazing how complicated it can be to get something reliable or a reliable map of the distribution of a species. One would suppose, okay, we are in the 2023, that should be something easy. Having said that, I was checking Wikipedia. I'm not sure if this thesis should be entitled Black Sea, but perhaps Black Sea, Sea of Marmara, and the Azov Sea. I would be careful with that kind of stuff.
In my
But that's not my question. Okay. My question is, do you think? Because I have many questions. Okay, but my question is, how would you, or can you relate your research with the theory of island biogeography, if you know what I'm talking about? Otherwise, we can talk about other stuff.
Yes, but no, I didn't. But
you know what I mean.
Yeah, but that's like kind of what looking at all the indices and all the functional diversity and stuff is. But especially if you're talking specifically about the Sea of Azov, the Black Sea Basin, and the Sea of Marmara, is that what you mean in terms of the island biogeography? Yeah, I didn't look into that.
And the rest of the Mediterranean.
And the rest of the Mediterranean, yeah.
Perhaps a direction?
Yeah.
And also, answering a bit, I think that all the information that you provide can serve as the basis for other management of this area, and for the prioritization of conservation areas and things like that. Do you think that?
Yeah. I think so. I think it's. Yeah. But so to answer the first part of your question, the JFCM, so the General Fisheries Management, they consider the Black Sea as the Sea of Marmara, the Sea of Azov, and the Black Sea Basin, which I wrote in my thesis, but there's too many things to include, so I didn't, yeah.
Okay.
So.
Congrats.
Okay.
Great. Thanks very much, Stephanie.
Thank you.
Okay, so our next and last speaker in this session is Victoria. Victoria is going to talk to us about Atlantic mackerel and work that she's carried out in her thesis. Over to you.
Good morning, everyone. Thank you for being here. So my project was focusing on modeling the transport and growth of Atlantic mackerel early life stages. I've never done modeling before, so this was like incredibly exciting to do and to see how it works. It was just amazing. So just to give you a bit of an overview, so first I will give you an introduction on the topic, what we know about it, and what are the questions that we kind of asking. Then we will move on methods. I will tell you what data sets I used and the area that we focused and the model that we implemented. And my project is not finished yet. So I've only got partial results, and then I will give you some of the action points that I have to finish my project. So introduction, I'm sure you've all heard of Atlantic mackerel. It's one of the most important and widespread commercial species. It occurs on both sides of the Atlantic. On the eastern part, it's valued over 1 billion of euros, so it's incredibly valuable. And I don't know if you follow any fisheries news, but it was like a whole drama around agreeing on this year's quota. But they actually managed to sign. And for this year, you can see there, that's the quota. And that's actually 1.6% decrease from the last year. So moving on to the larvae, which are the focal point. Here on this map, you can see the spawning area. So the mackerel starts moving up. So this area is divided, it has like 3 components, kind of. We have the southern component, the western, and the component in the North Sea. So I will be in my study, I focus on the western component. So they start spawning as early as February and they can spawn up till August, but the peak period is kind of May to July. Then they go through quite a few developmental stages. The yolk stage can last around 5 days, then the larval stage around a month till they reach 10 millimeters. Then is the post-larval stage up to 15 millimeters. Here they start a vertical migration, and then they enter the juvenile phase where they can actually migrate to places. They can actively swim, and they reach maturity around the age of 2. So the interesting bit is the growth. So from previous papers, we know that the growth of larvae is density dependent. On this graph here, you can see that from the 90s, there been quite a bit of a decrease in the length of, this is kind of like zero-age mackerel, so that's what they got from the surveys. And that decrease was kind of accompanied by this northward expansion of the spawning. So these dots here are all egg densities. They are like eggs that they got from the triennial egg survey from ICES. So you can see, like, as they expanding, the growth is kind of decreasing. But the real interesting bit happened in 2013, which is not here, where this kind of relationship broken down. So 2013 was characterized by really widespread spawning, so the densities of eggs were really high, but actually the length afterwards, what they measured, didn't decrease. It actually increased a little bit, which is suggesting that there is something more going on rather than the growth is not only density dependent, behind which the main mechanism would be food availability, but that there are other things coming in and determining the length. So what we tried to do is to release the larvae through a program and to see based from a model, like an oceanographic model, to see where they're gonna be transported. And this model allows us, to incorporate growth, so we can see, we release them from certain areas, where they're gonna be transported, and what length do they gonna reach. So are there areas that are high growth areas? Do they grow somewhere better than other places? And it's quite important to recruitment as well, because it determines, it's like there's so much going into management afterwards, you know, like recruitment is one of the most important, like will they survive for certain areas, will there be areas with high mortalities and things like that. So what I used 3 types of data sets. The first 2 are from ICES, and the third one was provided by the Marine Institute Ireland. As you can see, they are for different years, quite a bit. So we went by the ROM model, which we have data from 2013 onwards, but we will be only using 2013, 16, and 19, which we can also combine with the mackerel egg survey, and then see from the international bottom survey, kind of the results, like, because that's the first time the international bottom survey when they start catching the juveniles. The smallest one that they catch are around 7 centimeters, but like the majority are around 15. So that's the first real information we have where they end up. But between this data set and this one, we have no idea where they're being transported or what's happening. And yeah, so these ones are the areas that we're focusing on. If you remember the map before, it kind of coincides with the egg distribution. And yeah, so as we all know, transport, it's so difficult. It would be so difficult to go out to the ocean and try to sample the larvae or something and try to examine the transport processes by like conventional methods of surveys. But in past decades, we've got a lot of modeling coming in. And here comes this model. It's ICTIO. It's like a free Java tool designed to study the effects of physical and biological factors on the dynamics of ichthyoplankton. It includes the most important processes such as spawning, movement, growth, recruitment, that are really important in the early life stages of the fish. So in our model, we included spawning. So we set 3 release times that are coinciding with how they actually spawn, but what we know from the mackerel egg survey. We set out the zones, and we can also determine the number of particles that we want to release. Then we're trying to include vertical movement. So from 10 millimeters up till 50, they start vertical migration. And we included also temperature-mediated growth and mortality. So there is set a lethal temperature for eggs. And also if the current would transport them too close to the shore, or it would take them to the shore, they would obviously die and they would get a state. So the results, I really wanted to show you an animation, but I couldn't upload it for some reason, so it's just pictures. So you can see like these are the zones and we're releasing in batches. And that's random, totally. And then you can see as the current is starts to take them. So we know that in the Celtic Sea, we can see that there is no as much turbulence going on compared to the northern areas. And here it's also showing us the length. So in the second picture, I think it's more obvious. You can see that here the light, the color is transitioning much faster compared to the northern area, which is still quite blue, which was quite interesting. If you remember from Monday on the presentation when we saw the underwater current, if you look at the animation, you can actually see exactly it's the same way as these particles here were moving. Just like super exciting to see. And, yeah. And this was after 30 days. You can see they've grown quite a bit. Here they didn't disperse as much compared to the northern area. You saw those little boxes and now suddenly they are everywhere. Yeah, and that, yeah. So what we're comparing to, we've got information from the bottom trawl survey, as I mentioned, that's the first time that they caught. And we know that they end up quite close to the shore, and we can see the length. If you remember also from the first graph, as I mentioned, till 2013, you could see quite a bit of a decline, but since then, it's almost like it's stabilized and maybe a bit of an increase as well, which is quite interesting. And then we try to do a generalized additive model to see if we can predict the length based on where they are and how can we explain it. So from the survey, we had quite limited information. So we included latitude, longitude, year as a random effect, and then density, which was very tricky to calculate from these surveys, because obviously each country is using different things, and then it's quite difficult to standardize. Yeah, so that's what we got. We kind of expect our larvae The ones that will be more south in the Celtic Sea to grow faster. And also in some areas, as you can see here, there is quite a bit of a variability between the years. There is not really a general pattern, but we can maybe explain that with the environment that's happening in the sea. Maybe there were certain currents that year or the temperature that year and things like that that affected it beside the other things. And so what's next? So it happened this week as well. So we kind of settled on the number of particles we're going to be releasing in our model. We just wanted to make sure that if we release different number of particles, we still get the same results. So there is no density dependency, which is one of the assumptions of our model as well. Then we're trying to incorporate vertical migration, which is quite difficult. So in the model itself, we can only set like a set depth. So but we want to do a range of depth, and we're trying to alter the actual source code. I've never worked in Java, so it's taking definitely more time than I expected, but learning, getting there. Then we're gonna extract the data from the model, and it's super easy. It comes as a netcdf file, and we can get the position of the particles at the end of the simulation, their length, which zone they were released from, and what's their state. Are they alive or they die? And then we're gonna compare it to what we know from the the groundfish surveys. And that's kind of all. Thank you very much for listening.
Thanks, Victoria. Just to allow time for all the questions, we'll start with the jury members, and then if the audience have any questions, we'll come back to you. So who wants to start?
Maybe you are always the last, so.
Yeah.
First, congratulations, Victoria. I really like your presentation. I had the opportunity to contribute the last year to a study about this species, so I know it has a fascinating biology, and it's very interesting. And there is also it's also a big deal. There is a lot of, there are a lot of interest.
There is, especially because it's so valuable.
It's probably the most profitable fisheries in the European Atlantic for sure.
There is.
I was waiting for them for maybe questions to have some time to simulate what you just presented, but let's just try to keep the dot. So the thing that surprised me most, and correct me if I'm wrong, okay? From what I understand, this species, or the big deal comes from the feeding, the spawning and the feeding migration of the species toward polar latitudes.
Yeah.
And you're focusing in an area, the spawning migration comes south to the Cantabrian Sea, and then they move north.
Yeah. So.
Can you explain me that and
how
that fits into
during
your
the winter months they're feeding north, and then so the spawning starts south, and they
south in Gibraltar or south?
South, Portugal. Portugal here in Gibraltar. So the spawning starts here, and they slowly move up. That's how it goes. So there is no it's still it's kind of still the same stock. So it's not different. The species that, for example, it's not different mackerel that spawns here and spawns here. The North Sea component is a bit more difficult. But yeah, it's like a continuous spawning. When I did the maps, I didn't include the time because basically time constraints. But when you map the data from the mackerel egg survey, and you put the year and you map it out by month, you can actually see how they slowly move up the coastline when they spawn. I don't know if that answers your question.
And how does that fit into your design?
Oh, so because it's time-wise, and also so we wanted to capture over here, because this area was actually identified from previous papers as very important areas. due to the density and how much they spawn there. So we wanted to know from that, like when exactly do they spawn there and in which areas do they spawn there. And we designed, and based on that, we chose the zones that we're releasing the eggs from. So it's literally simulating how they spawn in real life. Is that?
Yeah, no. The other question I have is, you showed a plot with the H0
Yeah.
length at H0, something like that. What does that mean?
So this data is from the groundfish survey. You can see it's Q4 data. That's when this is the first time when they catch mackerel juveniles in there. So it's H0 there. They're still juveniles. And this is the first time we have data about them, where they are and how they grow, like what's their length. That's the H0.
What does that mean? What does that graph tell me?
This graph, so it tells you that the H0 mackerel in these years, so they also modeled their length. So here you can see the little stars. Those are the real life data. And they also did modeling to kind of improve on it and model, and this is what they got. So, and for example, so the mackerel at H0 in 2000 was way larger than it is now in that area.
One or many?
No, this is many. Many.
That's the mean.
This one, they didn't took mean values because they measured. So you've got actual measurements of the length, and you just use those ones, like the raw data.
Yeah, I think I'm explaining
I'm not too sure if I got your question right. Maybe that's why.
No, that's fine.
Okay.
Thank you. So thank you for the presentation. So just a little bit continuing with the first question, that you focus in that, let's say, north area of your analysis is done in around the British Islands.
Yeah, so so these are the 3 release zones. We're releasing in the Celtic Sea, west of Ireland, and then west of Scotland.
Yeah. The thing is that in the previous graphs you show that you have a high density of spawning and larvae in what is the Bay of Biscay. So.
Oh yeah, but so it's because of the oceanographic data. We got it from Ireland, and this is the area that's covering it. So to get the oceanographic data for these kind of places, we would have had to contact either institutions from those countries or get other.
So you have selected that because this is the data that you have.
Yeah, so I did my thesis in Ireland, so it was focused on that area.
Okay,
yeah.
Because when you are studying this population like this, and when the decisions are taken by, let's say, government or international institutions, just how much people need or the country need to fish out, I consider, as you mentioned before, all this one population.
Yeah.
And considering that you have a high density in that region, so it would be nice just to find information on that and introduce in your model to get a more reliable, let's say,
like
species behavior in.
But those are also the settings. It's quite different. Like if you go more south, because the temperature-wise and things like that, it would be more complicated to include in the model. Because if we want to include growth, the temperature-mediated growth, they kind of grow a bit differently because they adapted. So it's very strange with mackerel. Like they spawn throughout this area. But where they spawn, it's actually like they have like this adaptation that the eggs, like they, for example, here they would hatch in 2 days, here they hatch in 10 days, and then it's like, you can put it all together, definitely, but it's like, would be very time consuming for a master thesis, and especially to get all the oceanographic data. I think that would be the biggest challenge.
I was curious just because you focus on that, and so in the intro you show one graph that with a high density there, and so you said maybe you are losing some kind of
Oh, no. It's just because that was from a previous study that was kind of doing the whole, but we're focusing on this area. Yeah. But I didn't want you to cut it half, you know.
And those, so as you showed that the size of the larvae, or it's just that decrease at the some years ago,
Yeah.
but then more or less it goes in
Yeah.
a dynamic
Yeah.
model of that. So you mentioned that this maybe is not only an effect of this kind of more common environmental barrier, that there are some others. So do you think about with these some others?
Yeah, like because mostly what they've done, especially with the decrease, firstly it was assumed because of food availability density, you know, more fish need more food maybe not available, that's why they're smaller. But we saw that in 2013 that wasn't the case. So we know that there is other things, which it could be temperature, climate change, maybe the temperatures are enhancing the growth, or it could be the currents, you know, there might be, because it's also, they prefer certain areas, like the dynamics of the ocean can also affect, like, they need turbulence in the water, but if it's too much turbulence, it's not good for the larval growth, but if it's too little, it's also not good. So we can see maybe in those areas that we're seeing more turbulence, that could also play into the growth that they...
And this can be in some way related with an overfishing. I mean that maybe that the individuals that reproduce are not so efficient that they were some years ago.
Could be also, yeah.
And so they produce small larvae that several years ago.
Yeah, could be as well. But to be fair, like the stock itself, it's expanding. Like there is more Atlantic mackerel now than it was 20 years ago. So I don't think so. It's necessarily the overfishing issue.
The size, I mean, the size that are captured, they are not.
Yeah.
So maybe they don't get.
Could be.
That they
Yeah.
had, 50 years ago,
Yeah.
so they are smaller ones.
Yeah, that's definitely the case as well, that they're smaller.
Thank you.
Yeah. So thank you, congrats for being here, for just reaching the last step of your master. I would like to congratulate you also, because the way that you explain us or give us the talk was really, you attract our attention. That's great, well done. So about that graph that we were discussing, like, you know, this 10% reduction. Yeah, I fully agree that clearly this could be, for example, artificial selection. I mean, if you are removing many genetic, in fact, despite the fact that you have quite a big stock in terms of numbers, what you could be doing is, since you are removing the big individuals from that population, with time, would you expect this? You reduce genetic diversity and the potential of those individuals to reach certain size. This is quite demonstrated in many different fishes. So could be at least part of the explanation. Yeah. I'm not saying that it's the only one.
No, I think that's, just to do it quickly, I think that's the interesting thing about it, that there is so many different variables coming into and contributing to this, what we see. It's not like one or the other thing, it's like the combination of all of it, and just to explore the different parts is like really fascinating and interesting, you know.
Definitely. So could you go to that graph where you are showing us? I think it's
the end.
The one that didn't. That one. Yeah.
This one?
Those
or these ones? Yeah.
Yeah. What you are showing us that there, would you have its high density? No. Would you have? Yeah, or you might be expecting on the south. I mean, the south, those that are not quite dispersed. Would you might expect it high density? However, they have. Correct me if I understood it wrong, but you have higher size, no?
Yes. So if you looked here, sorry.
This is the dependence.
Okay. So here they do seem to grow a bit quicker than that. But the number of larvae that we're releasing in each batch is the same. So our assumption in the model is that the density does not play a role in how they grow. It is a limitation.
But so the thing is, your model, you're just dropping there a certain number of particles, individuals, whatever.
Yeah.
But then if they stay together, the density is different from other parts, no?
Like obviously, like once they start spreading, it is.
Yeah. So the density is different.
Yeah.
However, the length in your model, I mean, those in the south are bigger than the other in the north,
Yep.
no? Okay, so that contradicts the what you mentioned
Yep.
as the so, and it's reported on how somehow can you correlate that with, because I guess this density dependent would be, I mean, depending on this, I mean, could change from one year to the other year depending on the conditions available there. So, do you have any evidence of that? That you can say, okay, at least certain years or whatever this was reported, like
So,
certain nutrient or whatever they are feeding on, or
So from the surveys, from the Mackerel X survey, we know exactly the densities in those, but it's triennial, so it's only every 3 years that we know what's happening there. But on those years, so how the survey works, they start and they move in lines, and they sample till they reach a point where they did not find an egg. So it's also an adaptive survey. That it's moving northwards. Like before, they didn't survey there because obviously there wasn't fish. But as they expanding, they moving the survey to the areas. Like they following it kind of and sample till they don't find it. So.
Thank you very much. Any other questions for Victoria?
Yeah, I want to ask about vertical migration. So they move in the water column like in space and time? Or
So once they reach 10 millimeters, they start undertaking vertical migration. So during the day, they would be deeper in the water column compared to the day. And during the daytime, they would be like around, let's say, 30 to 40, 20 to 40 meters. And during the night, they would be in the surface water, like in the 20 up 20 layer. So we're trying to incorporate that rather than having just a set depth that they all at the 20 meter depth strata. Yes, it could play into the growth and things like that.
Okay, good. That's it. Lovely. Thanks very much. Well done, Victoria. Thank you. So that finishes this first session. I'd like to thank all our speakers, John, Stephanie and Victoria, and thanks to our jury members. We have a coffee break now for half an hour and then start back at 11 with the next presentations. Okay.
Yeah, we'll stop the streaming just for a minute. Yeah. Start
University of Bergen, Laura Mireles from the University of Oviedo, and Aitor Ibabe from the University of Oviedo. So you have 15 minutes. I will go back 1 minute before the end. I'll wave my hand, and then we'll have the 15 minutes of questions. First by the members of the jury. Then people online can also submit questions by chat, and the people in the audience can also ask questions.
Okay.
So, if we are ready.
Yeah, all good.
Okay, so the first speaker is Arcantier.
Yeah.
Okay, so please go ahead, you have 15 minutes.
Thank you. So hello everybody. I'm going to talk to you about the behavior and the migration of trade shads in the Schelde estuary between Belgium and the Netherlands during the spawning migration. So to start off with, what are trade shads? In case you haven't heard about them, it's a species of fish. They're clupeids in the same family as herrings, you can see here. And they're very closely related to alley shads that you might be more familiar with here in the middle. So trade shads are distributed from Morocco until Iceland, including in the Baltic Sea. They're anadromous fish, so like salmons and sea trouts, they reproduce in estuary and rivers and then migrate to the sea to spend the rest of their life. And they're also heteroporous, so they reproduce more than once in their lifetime. Unfortunately, like numerous other anadromous fish species, they're facing numerous threats, including water pollution, migration barriers, and spawning habitat destructions. And as such, they were added on the Annexes 2 and 5 of the EC Habitat Directive, on the Appendix 3 of the Berne Convention, and they're also listed as endangered on the IUCN Red List for Flanders. And they were actually considered as extinct in the Schelde estuary, so my study site. So for the study site and a bit of context, the estuary is about 160 kilometers long, and it's separated into two parts. So the Westerschelde, which is here on the map from the North Sea until basically the border between the Netherlands and Belgium, and you have the Zeeschelde, which is the rest here highlighted in blue. And there's what's peculiar about this estuary, and there's actually a tidal wave until the first migration barrier, well, barrier in general in Ghent, but the shads don't go past Ghent. The Schelde faced numerous habitat destruction, and we had really, really poor water management in the last 2 centuries, which led to a lot of anoxic events, and lots of species, like numerous fish species, basically disappeared from the river because of the bad water pollution. And that was the case for the shads, so there was no shads for over 100 years, and they started reappearing in 2014 following improved water management. And in 2014 is when we also recorded the first spawning event sightings. So my thesis aims were to understand the different behaviors in the spawning migration of the trade shads in the Schelde to start off with, because we basically have very little information overall about the species, and it provided a lot of fundamental knowledge. Then I looked at the duration and the timing of the spawning migration stages, and then I linked the duration to the fish length, looked at the migration speeds, and then linked the environmental investigated the environmental variables impacting the spawning migration, and finally conducted an STST analysis, so selective tidal stream transport, basically looking at whether the fish using the tide to save energy during the migration. But unfortunately, due to limited time today, I'm only going to focus on these here highlighted in bold. So for my methods, I use acoustic telemetry. In case you're not familiar with it, it basically enables you to track a fish throughout an array of acoustic receivers. So how does it work and what do you need? You need receivers to start off with. So they look like this, you can see here on the picture. And this is a map of our array in Belgium. We have some in the Zeeschelde, some arrays in the Westerschelde, and some in the Belgian part of the North Sea. Then what do? We tag the fish with little tags of 69 kilohertz frequency, and the tags that we use are about this size here. And then how does it work? So when the fish, you can see here the shad with this tag, basically moves throughout the detection range of the receiver, that's when we get a data point with the unique tag ID number of the fish, and then obviously the ID of the receiver, and the date and time. And we do this, and we have that kind of data throughout the acoustic telemetry array.
So between 2019 and 2021, we tagged 60 trade shads. We had 20 returning individuals, so fish that came back to the Schelde the year after to spawn again. Then for the environmental variables, I downloaded them from the Hydrological Information Center. So it's data that's freely available online. And I looked at the water discharge, dissolved oxygen, water conductivity, sediment concentration, turbidity, water temperature, water flow velocity, and finally the tidal water level. And I linked these environmental variables to different kind of key stages of the spawning migration. And today I'm just going to focus on the entrance of this Schelde and the starting of the spawning behavior. Then for the STST analysis, I used the water level data as a proxy for the tide, and we had this at a 10-minute resolution. Then we formatted the acoustic telemetry data to detection events, and we linked basically the tidal stage, so whether it was flood or ebb, to this detection event. I then calculated the flood ratio, which is the proportion of flood, like the proportion of time within one detection event that's in flood. So when it's close to 1, it means that the detection event happened during flood, and when it's close to 0, it happened during ebb. Then I use the Actel package on R to calculate the speed between the receivers, and the LPAT package, the recursive, partitioning, and regression tree, to obtain decision trees for these 3 spawning migration stages. So the upstream migration, where they go like this, then the spawning, and then the downstream migration. Then for results, first the behavior, we observed a tagging effect following the tagging of the fish. And so you can see here, the shad just goes back to the Belgian part of the North Sea and the estuary where you have higher salinity, goes back to the spawning sites and then goes back down again. And it's a movement that was never observed the following year. Then we have the spawning migration that we basically separated into 3 parts. So the upstream, spawning, and downstream migration. And we classified the rest as feeding. So this is just preliminary, new results, and it's going to be more defined in the next few years. So about the tagging effect, it's also known as fallback. We think it could be like a parasite removal kind of behavioral reaction, because some fish go to waters with different salinities to get rid of ectoparasites in particular. There's also a tagging effect that was observed in alewife, so it's another species of shads that lives in North America, and they observed the tagging effect 15 days after tagging. But there's very little information in general in acoustic telemetry about the effect of tagging. And then for the feeding, as I said, it's going to be further defined, and it also brings a lot of exciting questions about what do the shads actually do when they're at sea and during winter. Then if we look at the timing, so you see here we have the date on the x-axis and the number of individuals on the y-axis. And this is the starting date of the upstream, spawning, and downstream migration. And then in the dark blue, you have the fish from 2021. And you can notice that all the fish, or like most of the fish that migrated in 2021, have a later starting date for all of the phases. Then 16 fish started the upstream migration before the 25th of April. The same number started spawning before the 28th of April, and 14 fish started the downstream migration before the 15th of May. So the timing of migration in general in trade shad is thought to be depending on where they are. So in Portugal, for example, they start migrating earlier in the year because you have warmer temperatures, and then further north, like in the UK, they're thought to start later. In the River Severn, for example, this river where they have a big trade shad restoration project, they have a mean starting date of the upstream migration on the 29th of April, which is quite later than what we observed in Belgium. And as I said, it's thought to be water temperature dependent. And just to highlight, there's a lack of knowledge on the emigration timing. So when the fish leave the estuary or the rivers, we have very little information about this in general. Then if we look at the environmental variables, when they enter the Zeeschelde, not surprisingly, we observed quite a strong seasonal pattern amongst environmental variables, and there were also differences between years. So you see here in the table on the left, we have the environmental variables that had a significant difference between 2021 and 2022, and then on the right, the ones that had no significant difference.
Shads also entered the Zisrade during a drop in the sediment concentration and turbidity. So here as an example, you have the time, well, the months on the x-axis, the sediment concentration on the y-axis, and each plot is 1 year, with a red line showing the date and time of entry in the Zisrade of the fish. So the pattern is particularly visible in 2021. We have 2 waves of migration in the river, and you see the first one happened before, in a drop in sediment concentration, and the same pattern was observed during the second wave, and no fish entered when there was a high sediment concentration. And they also arrived at the spawning site at a mean temperature of just below 13 degrees Celsius. Then I did a backwards stepwise selection linear regression, and it turns out that river discharge, conductivity, turbidity, water temperature, and year were the most important predictors and the timing of entry in the estuary of the Shads. Then if we compare results to other rivers where there are Shads, like the River Severn that I mentioned, they start spawning, they enter the river at lower temperatures than what we found, and in the River Elbe in Germany is quite higher. Then in the River Severn, photoperiod was actually found to be the most important environmental factors impacting the timing of the migration of the fish, but unfortunately we couldn't really look at it during our thesis because we didn't have time. And then all these environmental variables and their impact make us think about climate change and how is that going to impact the migration of the fish. Now, given the history of the species, it can be quite tricky, and how we're going to quantify this with precipitation changing and then impacts the water discharge and so on. Then if we look at the sort of spawning behavior of the fish, so we also saw a seasonal pattern and differences between years, similar table here compared to earlier, and they arrived at the spawning sites at a temperature of 12.72 degrees Celsius on average. Then we conducted the same model, and we found that river discharge, water temperature were the most important environmental variables predicting this sort of the spawning behavior in the fish. And you see here, these are the spawning events that we can see from the surface. If we compare results to another species of shad that's very closely related, Alice shads, actually increased river discharge and water flow velocity negatively impacts the migration of the fish, and especially the start of the spawning behavior. And we also have to remember that the starting date of the spawning behavior, what we classed as spawning behavior, doesn't mean that the fish starts spawning straight away. Maybe it reaches a spawning site and then waits a little bit until they have favorable conditions or until more fish arrive, and then they start spawning, but it's not something we can look at given the nature of our data. Then for the STST analysis, so just a quick reminder, when the flood ratio is close to 1, it means that the detection event occurred during flood, and when it's close to 0, such as here, it means that it only occurred during ebb. And then this one here is when it basically occurred during a mix of flood and ebb. So we can see during the upstream migration, 30%, the percentage is a proportion of the data that matches within that group, and the number at top is a mean swimming speed of that group. So we have a higher mean swimming speed during the upstream migration, during detections that occurred in flood only, compared to ebb only. And we also have a higher proportion of the data that occurred during flood. That indicates that shads use flood tide, so the tide that goes inland during the upstream migration to save energy. Then we did the same for the spawning kind of behavior, and we don't really see a big difference. So we have 24%, 20% between flood and ebb only and flood only, so it's kind of like the same proportion of the data, and the swimming speed are also very similar, which makes us believe that shads don't use STST during the spawning behavior. And then during the downstream migration, we see here when they use ebb only, it's 44% of the data that we have, which is quite a big proportion. And they also have quite a high swimming speed, whereas during flood only, it's only 11%. But interestingly, the mean swimming speed is very similar between the two. Then we can say that twig shads use STST during the upstream and the downstream migration, but not during the spawning behavior, not during the spawning time when they're on the spawning grounds. And we think of it, it kind of makes sense
because when they're at the spawning ground, they don't have to cover very large distances anymore. They stay around the same area. And there's also no active feeding during the spawning migration. Like this is saving even more energy using STST. There's no literature on STST in Allosa species, so we can compare it to European eels in the same systems in the Scaldo as well, where they also use STST during the downstream migration. And STST also means that when moving, the fish would stay close to the seafloor to basically not be taken away by the currents during the tide that goes opposite of the direction that they want to go. So to conclude, we here provide the first information on trade shares in the Scheldt. We identify the behavior of the migration and identify the migration timing. We also investigated environmental variables linked to the migration timing, and we had the first investigation of STST in trade shares. And yeah, it brings a lot of new questions that we can investigate with the new kind of acoustic telemetry tag type. And that's about it. Here's my reference list, and feel free if you have any questions.
Exactly on time. So I will ask now the other members of the jury to ask questions.
Well, first, congratulations for the work.
Thank you.
Just some notes for you. I noticed that there were a lot of slides and they were very, there was very low time to see the results, and so just like a little note just for improvement in the future. I would try to use a lower amount of slides with more information.
Okay.
There was a second that I just closed my eyes and then I opened it and the slide was gone.
Okay.
So I didn't see anything. Just like a...
Yeah, thank you. I'll keep that in mind. Thank you.
And so if you have the chance to continue with this study in the future, what would you like to work with? Or
there's so many things you can look at. Because my supervisor has been tagging the fish with a different type of tag that has a depth sensor. So that means that, you know, I said during the spawning kind of behavior, we don't know what the fish actually do. Because twait shads spawn at the water surface, you know, they slap their tail on the surface, and that's how we get to see these little waves from the shore. So with a depth sensor, we can actually, we would be able to track the kind of movement in the water column of the fish. And it could also give us a lot of information about what they do at sea. So if we have receivers like partnered, partners in the UK or the Netherlands or whatever, that detect our fish, we would be able to get that depth data on the fish at sea or like in other parts of Europe as well. And there's also data storage tag that he's been tagging the shads with, and then it brings a lot of new information.
And I understand that you chose this species because there is very low information about it. So
yeah, exactly. And they disappeared for the Scheldt of like 100 years, and very unexpectedly, well, the water, quality improved, but nobody was expecting them to come back because they're very, very sensitive, and their populations have been declining throughout Europe quite alarmingly. Yeah.
Okay. And just another question.
Go.
How did you take the fish, or how did you sample the?
So we catch the fish during the upstream migration when they're already at the spawning sites. The picture see. And then we use double fight nets to catch them. But we don't put the guiding net kind of perpendicular to the shore. We put it parallel because otherwise the current is too strong. So we have one fight. Well, imagine you have the river going like this. You have one fight net here, the guiding net, and then the other fight net. That's how we catch the shads. And then we just we make a little incision on the side between the rib, and then insert the tag, and then we do 1 or 2 suture points. And we also look at the sex of the fish while tagging.
And you said that the end was 60 individuals.
60 individuals were tagged between the 3 years, and 20 came back, like the year after spawning. But we don't know the other, obviously remaining 40. Were they predated on? Could they've died, in natural causes, or were they maybe too old, or because we tag larger fish, obviously, and after a certain age, maybe they don't come back. Obviously, we don't know why the other 40 didn't come back.
But the tag has the information of the specific individual. You know.
Yes. Every tag has a single, unique identification number.
Okay.
Yeah.
Thank you.
Thank you.
Okay, thank you, because because I really enjoy the presentation.
Thank you.
I'm not an expert in this field, but I understand everything, so
Well, that's good.
very good job. And I have just one question, because in this thesis you offer a lot of new information.
Absolutely.
And I wanted to ask you how this will affect the management of the species.
That's a really good question, because obviously they're also listed on different annexes and they have a lot of conservation kind of legislation behind. So I think legally the country is has to protect and conserve the species. I'm not sure of the details of how exactly the data is going to help the water management, but it's definitely going to be included for sure. And there's also different projects going on in Europe, like as I said, the River Severn, they're tagging Thwaites as like the Unlocking the Severn, in case you've heard of it, where it's basically the estuary where they're breaking down all the dams is for Thwaites. They're creating this massive amount of data and information. It's very exciting. And there's also tagging shads in other parts and estuaries, and hopefully the data can all come together and improve the conservation, like Europe scale.
Thank you.
Yeah.
Thanks. Thank you. I'm starting to work on these guys in
Are
the
you?
south coast of but anyway, where they've done a lot of work on it. But I have a couple of questions. But the first one is you mentioned that you didn't have time to work on photoperiod.
Yes.
On that question, and I'm not sure I understand exactly in what way you mean.
Because I chose to focus on the environmental variables that I mentioned, just because of the ecology of what we know of the fish. For example, the oxygen, we know they're very sensitive to oxygen, and then given the pollution of the Schelde, I also chose to focus on the water discharge and so on. So it was,
But I'm curious why it would take that much longer to add photoperiod into your analysis.
That's a good question.
I mean, how would you add photoperiod into your analysis?
Maybe we could look at the time of the day and depending on the different months, and then just look at the photoperiod.
Do you mean the number of hours of day? Is that
The number of hours of daylight.
So it's just a matter of going to a calendar and pulling that.
That's also
data?
true.
Is that right?
That's also true, yes.
Okay, so it could be done.
It could be done. I just didn't do it.
I mean, quickly rather.
Yes.
Okay. No, I was just curious what you meant by photoperiod.
Yes.
To see. No, that's really good. I was curious whether or not there was any. You had any inkling whether there was a size-dependent component to the timing of.
Absolutely, it could be. Because I wanted to use the sex of male and females in my analysis, but unfortunately we had 14 males, 3 females, and the other fish were unknown. So it wasn't really a good balance. So I decided not to investigate this part in my thesis. But Thwaites, obviously females tend to be a lot larger than males, particular. So there could definitely be size dependent and then sex dependent, like a difference between the timing of the migration and the speed as well. Because I didn't explain it here, but I found that larger shads actually have a much shorter upstream migration duration. So maybe it could, larger shad could mean females. So maybe females, have a shorter migration duration than males, but it's something that I didn't look at because I didn't have the sex. But there could definitely be a length factor in there. Yeah.
You did a lot for just 14 fish. That's great. Good.
Thank you.
Well done.
Did you use Vemco receivers or what?
Vemco and Telmo.
Okay. I was just curious about you had a good array, a lot of.
Yeah, it's a permanent Belgium receiver network.
And how does the detection range inside the estuary compare with outside in the North Sea?
Yeah, that's a good question. So Jan Rubens and other colleagues conducted a research a couple of years ago about the detection range in the Schelde, in the Belgian part of the North Sea, and obviously it depends a lot on the environmental conditions. You have very strong currents, the turbidity as well, the noise. You have wind farms being built everywhere, and it really depends. But I think in the Belgian part of the North Sea, it ranges from a couple of 100 meters. But in the Zeeschelde, my colleague are actually conducting right now the research to look at the detection range in there. Yeah.
Oh, so okay. Because usually you before the study you
that's also
find
true.
out the detection range is. I was wondering also, in many marine species, the spawning events are related to the lunar cycle.
That's true,
Did
yes.
you look into that?
I didn't look into it, no. No, but it would be very interesting to look at for sure. Yeah. It could be related to the tides as well. So STST goes into it. Everything's so linked, it's fascinating.
Any other questions from the jury? And from the audience? Yeah, we have time. We have another 5 minutes.
You briefly mentioned already the life at sea of the fish. Could you explain it a little further, if we could have more information or?
Yeah, so we don't, overall in trade shares, we don't really know what they do, where they go, what's happening when they're at sea. But with our fish, they were actually detected in the UK and the Netherlands during winter. So it means that the same population of, what we assume to be the same population of trade shares go to completely two different areas during winter and have a different migration. We were able to do this through the European Tracking Network, so ETN, where all the kind of researchers working in acoustic telemetry basically put all the receiver data together on a server that's managed by Vliz in Belgium, and it basically enables you to see the data and the detections of your fish in other countries where you wouldn't be able to do that otherwise. And then it goes, yeah. But there's a study actually that came out last year or maybe this year, in the River Severn, where they detected some of the sheds in Ireland, they had to cross the whole sea between Ireland and kind of Wales, England, which is a very long journey, and one of their fish did 950 kilometers, which is insane.
Is there any fishery for them when they're inside the estuary?
No, there's not enough of them. No, yeah, in Germany there used to be quite big fisheries, but obviously the numbers decreased and then the fishery just went away because there was not enough fish. And now they're obviously protected and you're not allowed to fish them. Yeah.
So I don't see any questions on the chat, only one congratulations.
Thanks.
So I think we can stop.
Okay, thank you.
presentation is by Chloe Ducot.
Yep.
15 minutes.
So hello everyone, my name is Chloe and I'm happy to present you my master thesis that I submitted about the nesting behavior of green and hawksbill turtles in Western Australia using satellite telemetry with Dr. Michelle Thomas in Australian Institute of Marine Science. So the life cycle of marine turtle is well known. They basically migrate every 1 to 6 years and they come ashore around every 2 weeks to lay their eggs during the nesting season that's lasting around 90 days. The parameters like the renesting interval, the number of clutches of eggs laid during a season by each individual, and the frequency of each nesting event in a season are very important parameters for estimating the abundance of a nesting female population, as it is poorly quantified in remote areas of Western Australia and everywhere in the world, mostly. So advances in satellite telemetry offers a mean for these parameters to be measured remotely, and the correct estimate, often underestimated by beach surveys due to the intensive effort and difficulties they require. So satellite studies have been used to quantify mostly movement behavior and distribution to assist in conservation management, and but they can also be used to measure nesting behavior, as the GPS are very accurate to provide info of when the turtle is on shore, like so hauling out. These parameters represent a knowledge gap mostly in Indian Ocean, as there is a paucity of studies on these parameters, or most of these studies are unpublished. The green and hawksbill turtles are 2 worldwide threatened species around the world, but they're doing well and better in Australia, and they're 2 of a large nesting population in Western Australia. So in these studies, satellite tracking dataset from 54 green turtles and 27 hawksbill turtles were compiled from Western Australia rookeries to estimate and analyze nesting parameters described earlier, to provide key information, to correct estimates of population abundance and account for nesting events outside the monitoring period. So the deployment from the nesting beaches in Western Australia were done from Dampier Archipelago around here, the Ningaloo Reef and the Scott Reef, so on the northwest shelf of Australia. So for a bit of context, the biggest city will be Perth, which is a few hours in the south. The data came from numerous individual studies, so they consisted of different tags and programs, which is very hard to do the same all the time. Transmitters provided both Argos locations or both Argos and GPS location, or some transmitters provided only Argos locations. They were equipped with a wet and dry sensor used to know when the tag was dry, as no transmission can occur under the water, and provided several data products to define haul-out heavens to know when the turtle was on shore. So the first products used were the individual haul-out heavens. So the start and end date and time were recorded of when the tag was recorded dry and when it was recorded wet again. So when the turtle was basically hauling out. The next one is the DDN, the deep, dry, and never. Each hour was recorded either as deep, so deep underwater, dry, or never, that's like in the water but not deep. And a haul-out event was defined as a continuous period of time where each of the hours was recorded dry. The next products were the percent dry timeline, so this was used when only Argos locations were provided. The percentage of each hour's where the tag was dry was recorded, and the holdout event in that case was defined as a continuous time period where the PDD was recorded dry greater than 85%. And finally, when only wet and dry readings were available, that was used to define the holdout. It was only saying if like the hour was dry or wet according to the tag position and the transmission. So combining these two data, the locations were plotted to see if the holdout events were actually on land, to see if the turtle was actually coming on shore to nest, and they were classified. Each emergence was classified as a successful, so the turtle laid some eggs, or an unsuccessful, also called false crawl emergence. The classification was made was based on the duration of the time spent holdout and the interval between two onshore events. A minimum of 8 days was required for an emergence to be classified as a clutch, as it is physiologically impossible for a turtle to lay clutch before that. From this, all the nesting parameters has been measured: the clutch frequency, renesting interval, the number of first crawl, nesting duration, and the length of residence on nesting grounds were gotten from the analysis. Also, some holdout events were recorded dry while the turtle was located still in the water, so that was defined as extended surfacing event, and this behavior was further investigated as unexpected. So for the results, the nesting was predominantly recorded at night. The green turtle nested 2 to 6 times, and some individual laid up to 9 clutches, while the oxbill nested 1 to 3 times, up to 6 clutches. In addition to successful nesting events, false crawls could be analyzed for some of the datasets, and the nesting success, which is the division of the number of successful clutches by the sum of the total of the emergencies regarding of a success, could be calculated. So the nesting success for green turtles was 32%, and while the hawksbill was 60%. The renesting interval for green turtles ranged from 8 to 14.1 days, with an average of 11.5 days on the left here. While the hawksbill renesting interval ranged from 10 to 20.5 days, with an average of 16.5 days. As for the mean duration, both species were the mean duration of the nesting duration was respectively 4.1 hours for green turtles and 2.5 hours for hawksbill turtles, ranging from a few minutes for the hawksbill, around 45, to several hours, around 7 hours for green turtles. So post-tagging, the green turtle stayed in the nesting grounds for 52 days, while the hawksbill stayed 44 days. The duration in the internesting area exhibited a strong linear relationship with the number of clutches evaluated. So the longer the turtle was staying on nesting ground, the more clutches they laid. So extended surface times were unexpected observed behavior. They occurred mostly at night, lasted on average an hour or less, but some individuals were recorded lying on the surface from 10 minutes to 10 hours, which is quite unexpected. A larger amount of these events occurred in the internesting area, so 51% of the green and 86% of the hawksbill did some surfacing on nesting grounds. The longer time of the duration of these events was longer for hawksbill in the internesting area, but surprisingly, it was the longer events were on the foraging grounds for the green turtles, but this is mostly due to 2 individuals from a Marian island that are feeding in what we call the Exmouth Gulf, which is which present a lot of sandbanks and reef, which could explain why it's happening longer here. So the value found were very consistent through each nesting areas, through each nesting beaches of cloud frequency and re-nesting interval. The values were compared to findings from previous research from beach surveys in other areas of the world, and were found consistent with the population of these other areas, and they fall within the worldwide ranges. Although Hawksbill re-nesting interval of Western Australia is greater. The value of the nesting success also are greater for both species as previously recorded, even if the knowledge about it is still poor. Sorry. So that shows the efficiency of satellite telemetry to record parameters like this for remote areas, and even suggests maybe the efficiency of satellite telemetry over beach surveys. The variation between the two species, so remember the green nesting success was 32%, while the hawksbill was 60%, could be explained by a higher number of false growths and nesting attempts, so like the turtle came on shore but didn't end up laying eggs, for the green turtles, which is decreasing the overall success rate. The reason under the extended surface times are unclear, as no such behavior has been recorded for these two species. Some studies suggest a basking habit used for thermoregulation, but as most of the events occurring in this analysis happen during the night, this is most unlikely. So another reason could be linked to the moon illumination reported by Fred Assanau, which reported that loggerhead turtles were spending more time lying at the surface when the full moon was out. So investigating the moon cycle during this nesting season could be interesting to see if there's a link. So the current research provides estimates of nesting metrics of the green and hawksbill Western Australian stocks, which haven't been reported before. But however, some limitations need to be considered. The tags were programmed differently, and the type of tags were also different, which introduced a potential source of variability, as the method employed could not be kept consistent across all datasets. Also, parameters were probably underestimated due to missing data or unusable datasets. The whole-out data was not always recorded. GPS was not always available, which could lead to missing events and could change the results. For better assessment of nesting behavior now, in remote nesting area, it is important that future satellites tags should be programmed with GPS receiver to collect these whole-out events and provide more accurate locations information. And as now, for the existing data sets, it is possible that are used mostly to use as movement behavior, distribution, and abundance. The researcher can employ this analysis and quantify the nesting parameters to enhance the understanding of the nesting of all marine turtle threatened species. Thank you for your attention.
Okay, thank you. That was well within the time. So we have plenty of time for questions.
Yeah, thank you for your presentation. It was very interesting. As I am not an expert on this field, I didn't understand the method, this satellite telemetry method. How do you obtain the data, this nesting parameters data? Are these images in real time or? No.
So the data sets are provided from, satellite tags are put on the shells of the turtles, and they transmit. So we receive a bunch of files, which consists mostly with locations files, underwater and depth, recording of depth and.
And why did you choose these two target species? Is there any specific reason for that, or?
We worked on these two species because they're two large nesting population of Western Australia, and the deployments were already be made for some studies on movement, behavior, and distribution, and the project was to extend it to measure nesting parameters.
Okay. And what applicability do you think that this information can have in the future?
Well, I think it's bringing a lot of knowledge about the methods and the analysis that could be applied for other areas of the world that are very remote and where beach surveys are very intensive and are very expensive to do. And it's bringing new information about their behavior that could help in conservation and management.
Thank you, and thanks for your presentations. It's true that I like it, but I have the feeling that some information is missing. Like, for example, one basic question is why you are doing that. What is the main objective of your presentation, of this work?
Yeah.
So I'm asking you right now.
Okay.
Why is so important your work? Because it's very important that you need to tell us why.
Well, it's mostly to fill that knowledge gap that Indian Ocean has about the turtles populations. Because several studies that I compared with were very old, not very recent, or were not done with a lot of individuals. So comparing all the data sets made from satellite data sets made through all the years could provide a lot of information.
And I was wondering, because also for the methods, all the information that you analyze is only about this satellite. I mean, for example, there's no people looking for the nesting.
No.
Just only satellite information.
Yes, from what I did, that was only satellite information.
Okay. And I found it really very interesting because you have such amount of data, and when you presented, a lot of questions come to our minds, I guess, like why this happened, why this value, why all that time over there. So my question related to that, and also to what you answered to Aitor before, is imagine that now you are the supervisor of these projects, and you have a lot of money, and you have the possibility of analyzing many other variables or doing extra work. How you will focus to answer all the questions that appear from your work? What would you do? Like, for example, you said about taking into account the moon cycles, or maybe, I don't know, weather. What would you do?
Well, at first, I was thinking about, I suggested, because I tried to see a difference because I got data sets from several nesting seasons. So I tried to show a difference between each nesting seasons, but I got only like 3 or 4 years, so I couldn't do it. So I was maybe thinking about looking at the difference between each season, so probably implementing tags every year, but it requires a lot of money. Indeed, it's very expensive and a lot of time, as it is very remote areas to access, so it's probably not possible at the moment, but something in that area. And then probably also the nesting areas doesn't seem to have an impact on the parameters, but that could be interesting also to look at through the different nesting seasons.
And for example, using other tools, not only satellites?
Yeah, I think so. I found out about a lot of, not a lot, but some studies were comparing beach surveys and satellite telemetry, and I think combining the two would be very helpful to have very precise estimates. but as once again, it requires a lot of people, a lot of money. So it's basically not doable at the time.
It's a huge area. The study area
Yes.
is a huge one.
It's several islands, but yeah, they're not very easily accessible, and yeah, it requires a lot of time there to tag the turtles, as the encounter with a turtle for the tagging is not always assured, so it would take a lot of time.
That's the reason why I say if you have all the money and all
Yeah,
the
exactly.
resources.
That will help for sure.
Okay, thank you very much for
Thank
the
you.
explanation.
Hello.
I have a very quick question.
Yes.
Could you produce any tracking maps?
Yes, I could, but
What
like,
do they look like?
well, from the tracking maps, you can see some aggregation on the nesting grounds mostly. So the turtle stays around there, so around 19 days, like I said. And then you're gonna have a huge track and very fast corresponding to the migration, and then another aggregation somewhere that's going to correspond to the foraging grounds. And it's usually a cycle, and they come to the same nesting grounds and forage at the same place.
And on their daily, if you follow an individual for
If you follow
90 days, do they move a lot or?
So when we're on the nesting ground, yeah, they stayed like in the area, so about a few kilometers, but they stay quite in movement still. But yeah, it's like really when we start migrating, we start traveling longer and a lot, so we have a definite travel. But yeah, no worries.
These tags that you use, what's their lifespan? I mean, can you get data for more than one breeding season, or can you get data for multiple years?
So I don't really know, because I'm not the one who put the tags out, but from what we talked about, the lifespan is very short, and there's a lot of uncertainties, like the tag could fall out, so the transmission duration is very random and it depends, but I didn't have any data from more than 1, maybe 2 years.
Because I think, if I'm right, most sea turtle species don't return to breed every season.
Yeah, no, exactly, every
so it would
1
be
to
really
6
interesting
years.
if you could have these tags giving
Yes.
like 10 years of
yeah, that would be
data. That
very
would be
useful
for conservation. And the other thing was, I don't know what the sizes of these populations are,
yes.
but what, in terms of experimental design, I mean, how do you determine what's the minimum number of turtles you need to tag, and what sizes, for example, because there are differences in behavior between the large, older, experienced females and maybe the first-time nesters and stuff like that. Do you have any idea on that? Or?
Not really. So, like I said, I used the compiled data sets already made, so already deployed for the movement analysis. But I'm feeling like the biggest the sample size is, the better the result is gonna be. But yeah, I think if we're using only a few individuals, it's not gonna be representative enough of the population for sure.
Still, it gives you some very interesting
yes,
results compared to having people walking on the beach.
Yes,
at
yes,
night
exactly,
and
yeah.
all that kind of stuff. So,
yeah.
Any questions from the audience? Yes.
Yeah, I have a question about random, but like I know in Western Australia they use the calling program a lot for sharks, and I was wondering if you guys from the satellite tags saw any interactions with turtles and calling.
No, I never heard of it.
Okay.
No, that doesn't ring a bell. Sorry.
I was wondering, maybe I just missed it, how many turtles were actually tagged? Like, how many turtles were you dealing with?
So I was supposed to be working with 138 turtles in total. So that would have been 96 green individuals and 47 Auxbials, but due to the lack of rollout data or GPS, I only used 54 green turtles and 27 Auxbials. Some data sets were really not usable for that kind of analysis because they provided only locations, but I didn't know if they were onshore, holding out, or anything, so that wasn't helpful.
I have a question regarding like why you assume as a successful when they went out to the beach?
Sorry, I can hear you.
Why you assume as a successful like nesting
Yep.
when they went out to the beach? Because like usually they don't like they put their eggs, but there's a lot of time they go out,
yes,
do the hole, stay a little bit, but they don't put anything and they
yes,
go back.
that's why it was based on the duration they stayed holding out. So it wasn't the nesting duration properly wasn't recorded in Australia, but some studies did it for other areas of the world. So we kind of know that hawksbill takes around an hour, more or less. They could be faster than that, and the greens are going to take more than 2.5 hours. And so we based from that, and also the amount of days the turtle was coming back to the shore. So if the turtle left the beach but she didn't came back before, so a minimum of 8 days, that means that the previous 7 was a clutch because she stayed around to take the time to reproduce some eggs.
The last question.
Yeah.
What did you? There was like some kind of verification of the successful nest.
Some kind of what? Sorry.
Verification. Because usually, like, there's a lot of, for example, like if there's like a huge wave season,
yeah,
they can get flooded and they don't like this happens very often. So. Like,
yeah, no, not really.
No.
I never went on the study area. The only one that we could be sure of is the one when the turtle was tagged. The researchers reported if the turtle nested when they put in the tag on or not, but that's the only one we're really sure about.
Thank you.
So, did you submit already? Or?
Yes, I did.
Bonus. And,
welcome everyone. My name is Afonso Gomes and I'm going to be presenting my thesis work that has been in development for the past 6 months, and I'm glad we finished it. And it's focused on assessing the impact of Typhoon Rai on fringy reefs along the coast of Malwal in the Philippines. As you may know, coral reefs are key social-economical ecosystems as they provide food, coastal protection, and cultural value for many countries around the world. However, until now, anthropogenic and natural events such as typhoons have been estimated to have affected around 70% of all coral reefs. Typhoons can affect coral reefs in two different ways, either by physical damage or through water quality change. By physical damage, wind and wave action can break coral heads or even detach them from the substratum. Through water quality change, the intense rainfall from the typhoon can increase the turbidity and therefore hinder coral growth or even kill the coral. Many organisms depending on these corals can also change. Typhoon Rai, locally known as Bagyo Modet, was a typhoon originated in the equator and they had followed the northwest path to the Philippines. And on the 6th of December 2021, it struck the Philippines with winds reaching up to 195 kilometers, enough to make it a super typhoon. It was estimated to have affected around 7.8 million people with widespread flooding, landslides, and infrastructural damage. Our study assessed the impact of this typhoon on the general coral reef health in the Malwal area by analyzing two different time points and focusing on three key coral reef indicators, such as coral cover, fish and inverted abundance, and diversity. And these were analyzed at different predefined sites and between protected and non-protected areas. When I mean protected, is marine sanctuaries. Between February and March 2023, 9 different sites were surveyed and 8 matched the previous data from before the typhoon. For each site, 8 to 16 consecutive transects were performed with a length of 25 meters, giving a total of 88 transects on a range of 2.2 kilometers. For each transect, coral survey using PIT methodology, short for point intercept transect, was used to analyze percentage cover of life form categories. Fish and invertebrate surveys were used to analyze abundance and diversity, and rugosity measurements and as well as environmental measurements were taken. For point intercept survey, the transect was laid down along the reef crest, and at each meter intercept, the life form was recorded. In this example, you can see that at the first meter, rock life form would be recorded. After this, fish and invertebrate surveys would be conducted, where all the fish species, all the species and the number of individuals would be also recorded. And this would be on a 2.5 meter range from the transect line. On the way back, a rugosity chain would be laid down over the coral reef to conform the coral reef, and the final length was registered to calculate the rugosity index. This is all the material used in the surveys. You see that's quite a few materials that I had to transport. I can highlight the measuring tape of around 30 meters, enough to cover the transect, and the refractometer here to measure the salinity. All the previous data was collected by the Thresher Sharp Research and Conservation Project. They conducted 2 independent surveys between in April and May 2019. However, these surveys focused on different sites, and we decided to combine them and compare it to the present data. They also did not include reef rugosity and other abiotic variables, and the data was going to be used for future research. Before moving on to data analysis, life form categories from the coral survey were grouped into broader categories. And for fish and invertebrate surveys, it was observed different species lists. Therefore, to avoid any biases with abundance and overall species richness, main analysis focused on alpha diversity index, as these take into account the number of species. Regarding the data analysis, generalized linear models were used to assess the effect at each of each coral indicator, at each predefined site, or between protected and non-protected sites. If this difference was significant, a priori multiple comparison tests were performed using IMBRSea package from R. Moving on to the results, there was a clear shift in coral life forms from before the typhoon, where these were mainly composed by hard coral and abiotic forms, to mostly abiotic and algae. And this can be explained by the direct impact of the typhoon, as coral rubble increased and increased. There was also, through the GLMs, significant differences between the sites for all of the life form categories, as it is expected, because the sites from before the typhoon showed different percentages of those categories. For Talisai, you can see that there is it's the highest significant difference, with a reduction in 59%, and this was mainly due to a hard coral decrease. Interestingly, soft coral increased in some of the sites, and this could be explained by the shift of hard coral bottom to soft coral bottom after the typhoon. That coral also, interestingly, decreased in some of the sites and increased in one of the sites. And this can be explained by the different types of impacts of the typhoon. So if you think about it, hard coral decreased in Talisai, and you can see that there is an increase in their coral in the same site. And this can be explained by the water quality changes, which could have been a result of bleaching or just increased turbidity. And then in the other two, Tonga and Tobol, this decreased mainly due to the impact of the direct impact of the typhoon, which is corroborated by the percentage of algae, increased percent of algae, and abiotic categories, where coral rubble is part of. I decided to show also coral branching because they are known to be easily breakable, and you can see that in many of the sites they show a significant decrease. There were differences between the percentage of change between acropora and non-acropora, and this could one more time be explained by the shift of acropora mostly to non-acropora. And rubble, as expected, as I mentioned previously, increased in many of the sites. Regarding non-protected and protected sites, only a few of the life form categories showed a significant difference between those. And I want to highlight here the acroporal life form, where you can see that both site types showed a decrease, but a higher decrease in non-protected. and this could be explained by the nature of the protected sites, where they usually recover faster over non-protected sites. For fish survey, as I mentioned, you can see on the left graph, there was a five-fold increase in abundance and species richness, and we believe that this was mainly due to the species, different species lists used. However, there can be also that climate change and fishery effort change over time, so more investigation needs to be done. But if you look at here, which shows up the diversity indexes, you could see that mostly all of the sites with the Shannon winner increase in diversity. Using Gini Simpson, it decreased, it didn't increased, but in the different sites, in fewer sites. And Piolo's evenness decreased in some sites, and this could explain a higher diversity after the typhoon, but a lower evenness overall. For fish, for protected and unprotected sites, I want to still bring attention to abundance here, as in non-protected sites the difference was much higher, and this could be probably due to one of the sites present, which is Sardines Run, where there's a school of sardines present, and therefore it skewed the results. But if you look at the diversity indexes, you see the opposite. You see that diversity index increase in protected sites, and this, one more time, could be brought to the nature of the protected sites, as it is expected to have less human impact, such as fisheries. For invertebrate survey, an overall decrease of diversity and evenness was found, and I just want to show that the only sites that didn't show any significant differences were Osriff and Tobo Sanctuary. Between protected and non-protected sites, there was a higher decrease in protected sites, and this could be explained by the change in coral and fish diversity. Regarding the diversity indexes, non-protected sites show the overall, for the three of the indexes, showed an overall higher decrease than protected sites, and this can also be brought to the nature of the sites, as protected sites usually tend to recover faster than non-protected. Bringing out to the conclusion, we found that there was a change in coral reef health between the two time points, and this could be a reason of the impact of the typhoon. For corals, there was a shift from a majority live coral to a majority of rubble and algae. Contrary to expectations, fish diversity and evenness significantly increased, and further investigation needs to be done. For key invertebrate diversity indices, there was a significant increase. However, we need to acknowledge the limitations of this study that range from an imbalanced nature of the data sets, as different replicate transects, different number of transects was done for each site, and the possible influence of factors unaccounted, such as climate change or the environmental variables, which were excluded. Therefore, for future work, we will need to continue analyzing this. Thank you. I want to thank the people that helped me, my research in the Philippines, and to the people at home, I love you.
Thank you. Within time.
Thank you very much for your presentation. It was very visual and very interesting. I wanted to ask you, did you use the same sampling methods than the ones that were used before the typhoon?
Yes, so information was provided so I could do the surveys, but it was broad. But they brought that it was done point intercept transect, fish and invertebrate surveys, and that's why the fish and invertebrates list was different, because I did not have access to the list that it was done. I was just set to survey as much as possible and detect as much species as possible.
Okay. And you said that there were some sites where you noticed more decrease in live coral than other ones.
Yeah.
Do you think, or why could this?
You're talking about protected and unprotected, or just the overall? So I can put in protected and unprotected because all of them are included. So from the data that was collected, we found that there was a high, before the typhoon, there was a higher percentage of hard coral and live coral in sanctuaries, which is expected. And therefore there is a higher chance of those corals to be destroyed. So if the decrease is higher, is probably due to the previous amount of corals in that area.
I was thinking more about maybe some sites are more sheltered, or did you compare the sites, the conditions inside?
The conditions, no, because I didn't have. What do you mean about conditions?
I mean, maybe some sites are more sheltered, so the typhoon has not so much effect, or maybe water temperature that can affect corals.
Yes.
This type of conditions.
It would be an interesting topic to. That's why I also collected that data, because while I was doing the surveys, many questions and many ideas came into my mind. But since the data previously did not account for that, it was not possible. But I feel like future work should be done in that regard.
Okay.
Thank you.
Thank you, Hector, and thank you, Alfonso, because I think it's a great work in a hard one, because you already go sampling. And I spent a lot of months sampling for fishing, corals, and invertebrate diving, and I know it's a hard work. So congratulations.
Thank you.
And the only teeny detail, but not to feel bad about that, is that you have an amazing work, but you choose a wrong combination of colors. It was very hard to read the first slides with the black background.
Okay.
It was not so easy.
I feel like it's the difference from the projecting, because here in the screen I should have tried to. I like it though. I like it.
Yeah.
So, and about your results, for example, you said that invertebrates decrease and fish increase.
Yes.
Can you go a little bit deeper with this relationship?
I tried to investigate some relationships from the fish species found and the invertebrates that I was analyzing, but the invertebrates were mostly starfish, like the crown of thorns, and I don't know if parrotfishes or triggerfishes feed on them. No. So yeah, that was my thought. I didn't divulge much into that, but it would also be nice to compare and see if there's a community change on fish affect also the community change on invertebrates.
Yeah, because without data, when you see that, I was thinking maybe just the fish increase and eating the...
yeah, but I don't know which species specifically eat those invertebrates.
Okay, thank you.
Thank you.
Yeah, thank you very much. I was going to say that just because they've changed doesn't mean they're direct, they can have an indirect effect. Like the starfish have come in and eaten all of the prey that the fish
Oh,
would
okay.
have otherwise. So you should investigate that a little bit.
Okay.
How would you do that?
How would I do that? So first I would need to still do a fish survey to see which species would be present there, and to go on the food web of those fishes and see which ones they usually predate, and if they are found in those, and if they are found to have decreased, if the fish that are found to have indirect impact on the invertebrates would decrease, that would mean, and the direct invertebrates that would, I need to think more about this.
I was actually curious to see how would you test them together.
I think it would be mostly on numbers and so abundance of certain species, and if I would see a decrease and an increase in a lower food chain, maybe I could take some conclusions from that. But yeah, I think I would take that approach.
Can I ask so I want to go back to the exposure sheltered thing. That was my big question, because I found it difficult to remember which reef was which when you were talking about the differences between them. So can you explain a little bit more about the different characteristics of the reefs?
Do you want me to show the slides with the?
Yeah, and maybe can you relate those characteristics to the differences that you found?
When I mean protected and unprotected, it's not sheltered.
No, NPA, that's NPA.
NPA, yeah.
But we want to know about their location and characteristics.
So, let me move here. So, all of them except Sampaguita or from the previous survey, and here the currents are mostly southwest. And there was more exposure to waves here and here. And what was your question related to that?
Well, we kind of wanted to know which ones then would be more impacted directly by the typhoon.
The typhoon came, if I can exemplify, the typhoon came from this way. So it was outside. It didn't went on this side.
Okay.
But I feel like if I sampled, for example, here, there would be more impact, I believe, as here. It's quite flat, this area, so I don't know if it would be quite different. But if I would sample here, I would expect some significant changes.
So is there any way that you could group your sites that might...
Oh, you mean in like south and north?
Yeah, or, into the current or out of the current, or parallel, or whatever?
Yes. One of the parameters that I analyzed, I don't know, yeah, current, it's spelled wrong. Current, I also took that, so maybe for future research, it can be that. But I didn't have that data previously, so...
But the current wouldn't change.
True, you can access that online.
And the temperature probably would change, and the depth probably would change. So...
temperature can change nowadays with...
but just because you've measured it now doesn't mean,
because I thought...
curious why you
I was talking with a lot of dive shop because I had to go around the island, the spot. And most of them say that the temperature is rising, and it used to be like around 28, and I found around 29, 30. So it could be one of the interesting points.
But the other things you could have used, right?
I apologize,
Current orientation.
Yes, I feel like I already did many if I only focused on corals or one of the health indicators, maybe I could have divulged into that. But I focused on the 3 fish and invertebrates also. So doing that in this short period of time, I don't think it would be feasible. Thank you.
I have there's a question online which is related to what I was going to ask, but I'll read the question. It's from Simon Oliver. How do you interpret the increase in fish diversity between the 2 time periods? My question is also related to that because the before and after, it's for the same season.
I apologize. Can you rephrase
the question online is how do you interpret the increase in fish diversity between the 2 time periods? And I was wondering also, is that the before and after study was the same time of the year because there could be a seasonal effect?
No, it was around the same time of the year. So April and May, and I sampled February and March, which is already after the typhoon season. So not a lot of impact is done. But I could divulge more into why it increased. And one thing that comes to mind is, for example, if from before in all of the sites the fishing effort was greater, and then after the typhoon the fishing effort was lower, maybe it could explain also the increase in. I don't know if that answers the question specifically, but.
The other question I had about the methodology, about the point-intercept method, wouldn't you miss smaller species with that if you use that?
Yes, I quite went into a lot of research about it, and because there's line intercept transect, which takes into account the continuous. So if you take from 0 to 1, you register this, and from 1 to 1.5, you register another life form. But I found a paper that combined all of the methods, and they said that for mostly non-super expert identification skill or more newer researcher could be used with less effort because it would be more hours in the water and with less people, because I was also alone doing this surveys.
Any questions from the audience?
It's more like theory, because I mean the typhoon was right before COVID, so potentially COVID and like the curfews that were present in the Philippines would have decreased the fishing pressure, which could increase the rebound in the abundance.
Thank you for bringing that. That's a good point.
It's just a small question. Do you know why the first survey was made in 2019? Because I didn't know.
It's just a survey that was done. They were collecting data.
Okay, because of the implementation of protected areas, or nothing?
It was not previously thought to be for this research. It was just collected for future purposes.
Okay, just for sure.
Perfect. Thank you.
Okay, one last follow-up question from Simon Oliver, who says, no, the fishing effort has always been the same. What possible ecological effect might explain the increase?
From the coral change that happened, many fishes that I read in fish base, the ecology, they prefer to hide in crevices of Heliopora or other Acropora corals, and because if the hard coral covers still remain the same, maybe it would be from protection of the corals. Climate change and the increasing temperature might, because I surveyed on the reef crest, so fish that prefer a certain temperature might have gone a little bit deeper to find that temperature. but that's a decrease. So I apologize, but I have to look into that in deeper.
No problem. Okay, I think we have to stop here because we have to.
Yeah, perfect.
Thank you.
Yes. Enter.
Yeah, just with the arrows.
Okay.
So our final speaker presentation of this session is by Isabel. So Isabel, 15 minutes.
Yeah, thank you. I'm Isabel, and I'm presenting my thesis, which is a demographic analysis of pelagic treasure sharks in the Visayan Sea in the Philippines by using stereo cameras. And this project was also done with the Treasure Shark Research and Conservation Project and with the supervisor Simon Oliver. So there are 3 species of treasure sharks in the world. The common and big eye treasure also inhabits the Atlantic Ocean, and the distribution of the pelagic treasure sharks is, as you see in the map, in the Pacific and Indian Ocean. They exhibit very slow growth characteristics, which makes them vulnerable to overexploitation, and they're listed as endangered by IUCN. They were also added to CITES Annex 2 in 2016, which prohibits the trade and exploitation of the species. It's very easy to distinguish males from females because the males have these claspers, which are their reproductive organs. The reason I studied it in the Visayan Sea is because they are known to frequent, they have been known to frequent at a seamount in the Visayan Sea, known as monachol, and they visit this seamount frequently to benefit from essential parasite removal at cleaning stations, where little cleaning wrasses are eating parasites off their skin. And it's the only place in the world where you can see pelagic treasure sharks daily, because otherwise they're quite deep. And this has catalyzed the dive tourism industry in the area, which now constitutes an important part of the regional economy. And it was sanctioned as a shark and ray sanctuary in 2016, which prohibits any type of fishing. And it was also enforced by having guards at the seamount to avoid any fishing happening. So it's a very unique place that's well known for divers. Oliver and Viscos even documented a treasure shark giving birth at one of the cleaning stations in 2015. This is the only documentation of a treasure shark giving birth. So it's suspected that they're also benefiting from these cleaner wrasses during delivery, which further emphasizes the need to protect these important habitats. Oliver et al. Published in 2019 a study of their distribution. So this is a map of their potential daily distribution, which covers a very large area of 5 provincial territories, which increases their susceptibility to fishing. They're also known to forage at depths up to 250 meters, which makes them vulnerable to long lines in the region. And they're also suspected to comprise of a single unit stock. So they're suspected to be a close population, where we've seen some of the same individuals over a long period of time. However, about a year ago, dive operators reported that they were seeing less and less sharks in monachol, and they were a bit confused because they've been seeing them on a daily basis since the 90s. And soon after, they realized that the sharks were now frequenting at a smaller seamount, 8 kilometers southeast of Monachol, known as Kimud. And since then, dive operators have focused on Kimud Shoal, and sightings have remained very sparse in Monachol. But there's also cleaning stations in Kimud Shoal now that they're choosing to visit instead. Demographic modeling of sharks often or always depend on fishery-dependent data. However, bycatch data is not often detailed, as it might lack of life characteristic needed. And in some parts of the world, like the Philippines, it's non-existent since it's illegal to catch them. The demographic models normally used to assess fish stocks are not always suitable for sharks because of their different life characteristics. But one of the most important parameters in demographic modeling is lambda, or the finite rate of increase, which describes the population growth over time. So because of the increased vulnerability and decreasing shark population, there's a need for non-invasive alternatives rather than fishery-dependent data. And that's why I, in this study, incorporated stereo photographic methods. Stereo photographic methods includes 2 cameras that are placed in a slightly converging angle, and by pre-calibrating them, you can actually measure the distance, the sizes of objects within the camera. The same type of technology that are also used for 3D reconstruction. And the increased availability of softwares and lower cost of technology has increased the potential applications for this technology. And the objectives of my study was to investigate the population dynamics of the population and also to evaluate their sensitivity to fishing pressure in the area. The study also aimed to incorporate stereo camera data in demographic modeling, since this is not commonly applied, and also to facilitate the modeling of other data-deficient populations with this technology. So this is a 3D map of Kimud Shoal where I was sampling. It's a lot smaller than Monad Shoal, and it rises about 300 meters from the sea bottom. And I identified 3 main sampling points where I identified cleaning stations with a high visiting frequency. And I manually deployed the cameras for about 2 hours each time, as long as the camera batteries lasted. And then, this was my camera frame that was built from PVC and steel pipes. And the cameras were placed 80 centimeters apart in a 4-degree converging angle, which was recommended by Delosy et al. For measuring large pelagic sharks. And a back plate was also placed to secure the camera so that the cameras were in the same positions every time. And a calibration board, checkerboard, was used to pre-calibrate the cameras and moved in different angles and distances from the cameras to replicate possible positions of the sharks. And then an open source software, which is an R package called Stereomorph, could identify the patterns of the checkerboard and generate a calibration file. And so I deployed the cameras on a daily basis, and then I measured the sharks that were swimming by and also determined the sex. So this one is a female. And then in the Stereomorph software, I had the left camera view and the right camera view. So I marked the tip of the rostrum as well as the precaudal keel, from which I could reconstruct it into 3D and generate an accurate length estimate. Based on these estimates, all females that were used for demographic modeling were placed into different stage classes. So neonates, juveniles, subadults, and adults. They were categorized as. And for the demographic modeling, the fecundity was estimated as a continuous birth flow with a 1-to-1 sex ratio based on literature. And they were also estimated to have 2 pups each year and to reach sexual maturity at around 8 years. The natural mortality was estimated from 8 empirical estimations, from which the median was used as a constant natural mortality, and the longevity of the sharks were estimated at 30 years. And from this, a stage-based matrix was developed based on the stages, longevity, survivorship, and fecundity. Yeah. If you have questions, I will go into details. And then 5 different scenarios were tested to evaluate their sensitivity to fishing pressure. So for the first scenario, no fishing pressure was applied to any of the stages. For the second scenario, a 10% hypothetical fishing pressure was applied to all stages. Third and fourth one applied 10% fishing pressure for either neonates and juveniles or subadults and adults. And the fifth scenario applied 10% fishing pressure for all stages except for neonates. And to account for the uncertainty in the parameters used for the demographic model, demographic stochasticity was introduced to account for variability in the variables. And also risk analysis was conducted to evaluate the risk of the population decreasing. So for the cameras, from my video, 62 sharks were identified as females, 31 as males, and for 17 sharks, the sex could not be determined because of poor visibility or angle from the camera. And for the females, this was the distribution of stages that they were classified as. So as you see, the main, the one with the highest numbers were the adults and the juveniles. And for scenario 1, generated a finite growth rate of 1.0565. And as you can see in the graphs, it shows a slow but steady increase of the population. The stochastic analysis showed a greater variation because of the variation of the variables in that scenario. But yeah, this scenario was the only one where the population was actually increasing. And as you see in the stage-specific projection, the juveniles have the highest growth and also constitute the greatest part of the population. And all projections was done over a time period of 30 years. And for the second and fifth scenario, the ones where fishing pressure was applied to the most stages, both of them predicted quite a certain decrease of the population, both of them with a finite growth rate below 1, meaning the population is decreasing. And as you see in the stage-specific projections, the population is slowly but steady decreasing in these scenarios. For scenario 3 and 4, where either the juveniles and neonates experience fishing pressure or the subadults and adults, the growth rate is more constant, but slowly decreasing since the finite growth rate is below 1. But yeah, a more constant population size. For the risk analysis, the probability of the population falling below half of the initial population size was 98.3 and 99.7 for scenario 2 and 5, 0 for scenario 1, and between 20 and 30% for scenario 3 and 4. And the risk of total depletion of the population was 0 for all scenarios except for scenario 2 and 5, where 16% probability of the population being depleted. Let's see. So based on these results, the adults and the juveniles hold the highest reproductive potential of the population. So if the number of juveniles and adults decrease, that will have the greatest negative effect on the population growth. Stereo cameras in this scenario can provide a cost-efficient means of generating population data when other data is lacking, or the population would suffer dramatically from fishery-dependent data. And its increased availability also offers an increased application of this non-invasive method, especially for other species where visual identification methods are more established, for example, tiger sharks and whale sharks. And you could benefit from using stereo cameras for long-term monitoring of these populations. Compared to other studies, this study generated a very similar finite growth rate, which validates the parameters used in the study. However, this is a very low number, and treasure sharks are one of the species with the lowest productivity of sharks. It's also important to remember that data-deficient species holds a high uncertainty in the variables, so it's very important to introduce stochasticity in the modeling. And yeah, the highest sensitivities was the juveniles and adults, so the protection and conservation effort should be focused at them. So in conclusion, they have a high vulnerability to fishing pressure, and continuous monitoring is required, as well as enforcing protection of Keymet Shoal, where the majority of the shark we observed were adults and juveniles. So by protecting these aggregation sites from fisheries, it's likely a very effective conservation measure for the population.
Thank you very much for your presentation. It was very interesting. This is maybe a silly question, but why do you use two cameras? Why do you need two?
Because they have a different angle, but as long as something is in the same field of view and you know the distance between the cameras, it's like you can measure the distance of the objects because it's two different fields. Okay. With just one camera, you cannot do that. I know with like new smartphones and stuff, they have like several cameras, so you can actually measure stuff. Because
one of the parameters that you use is the size of the individual, right? Because I didn't understand also how did you estimate this lambda value?
That's from the stage-based matrix. Yeah, I didn't have time to.
Which parameters does it include?
So it includes. Let's see here. I will explain this. So this is neonates, juveniles, subadults, adults. Neonates, juveniles, subadults, adults. So this is the probability of the neonate surviving and remaining in the same stage. It's 0 because the duration of the neonates is just 1 year. So it's over a time of 1 year. So that is the probability it will grow and move on, survive and move to the next stage. And that probability is based on the survivorship of that stage, which was estimated from 8 empirical estimations, and the median from that was assumed as a constant. And then the fecundity of subadults moving on to the adult stage was estimated on the 1-to-1 ratio with 2 pups each year. So that's 1 pup. And then it's also dependent on the survivorship of both the subadult and the neonate.
Okay, sorry, I'm a little bit lost. So you took the images of these individuals. So this information that you have with these cameras is the number of the sex, the number of individuals,
yeah, so
the size?
Yeah, the size, which I use to classify them into stages, and the gender, the sex of the shark.
Okay.
That's basically the data
That's
I have. Yeah, to get the stage distribution of the population and then initial abundance. Then another problem is that we don't have an absolute abundance of this population because they're so difficult to identify individuals. They don't really have any specific marks and stuff. So yeah.
And regarding these lambda values, do you know which is the normal value of a normal population, which is not endangered, or I mean, which is the range?
I mean, it depends because there's it depends on the species. You know, like some like bacteria that can have like exponential.
I mean, we saw here values of near 1 or.
Yeah, so 1 is constant. More than 1 is increasing, and less than 1 is decreasing.
And this more than 1 the range is, we don't know, right? I mean.
Yeah.
It can be.
I don't know. Maybe Karim knows. What's a normal value for lambda?
For sharks?
I mean, for a normal population of a not endangered species.
For sharks, it's always very low. I mean, it's always very close. It's either very close to 1 or below 1.
It was just for me to make an idea to compare with a population that is not endangered. I mean, here we have values like 1,
close to 1?
Well, if it's above 1, it's
I don't know.
It's growing.
Can it be like 10 or
No,
20?
No.
No, but I mean, like, if, like, I guess, like, if humans have, like, 2 babies, then that's, like, 1, because you're just reproducing the same number that you already are to people, you know?
One is stable, one
Sorry,
is
I'm a little bit lost.
Yeah, no, sorry. Yeah.
Thank
Yeah.
you.
Yeah.
Okay, thank you, Isabel, because it was a very nice presentation. Visual, it was amazing with the videos and so on. Thank you. And it was also a very interesting research, because you see how the population moved from one area to the other one. One is protected and the other one is not yet.
Yeah, and it was like a long process to get the first one protected, and then they move.
So, my question goes to that way. Like, we all know that it's very difficult to create marine protected areas, and now you find one place where they are, and maybe if you find this rate of neonates and so on, maybe they reproduce also close to there.
Yeah, because there was like the documentation of a shark giving birth there, like further emphasizes the need to protect this area. Like a little bit off topic, but like we don't know exactly why they moved. There are now tiger sharks present all of a sudden in Monatrol, but we don't know if that's influencing their movement behavior. But also, when I was previously at Himochol like 5 years ago, it was just bare rock. So I think because of COVID, it kind of had time to regrow, and now it's very convenient for the treasure shark because it's closer to their hunting grounds, so just more convenient for them to visit there. But the shoal is so much smaller also, so it's more crowded for them also.
So maybe they just move also one side to the other depending on the ecology of this.
Yeah, I mean, we don't know. I have reports of like the treasure sharks being very frequent in Monatrol in like the 70s. So they have been there for a long time. Yeah.
Okay, thank you. Thank you very much.
I enjoyed your talk very much.
Oh, thank you.
Yeah, it's very good. My question was what distinguishes between a juvenile and a subadult, and how do you do that?
So I included the subadult stage basically because there is some uncertainty regarding their maturity. Like when they have fisheries data, they can see that, they basically, because literature has classified that stage as an individual stage where they might or might not be reproductively active.
Do you have any clue that they might be inhabiting different areas and therefore? So is it a stage that more indicates uncertainty in our ability to tell what's going on?
Yeah.
But biologically, do you think it has any, biologically or ecologically or behaviorally, do you think it has any basis in reality? Does it represent individuals that do something different?
I mean, they are like very slow growing, so you see there's like quite, I mean, they're teenagers, you know? So I'm guessing they're a bit more curious and like, you know.
More so than the juveniles.
I'm totally guessing, I don't know.
Okay.
Yeah.
What do you want to ask questions first?
No,
so let me ask you some questions from the chat.
Yeah.
Yes, so they know we haven't forgotten them. So one is, can you explain in more detail the camera frame that you used, and did you make it?
Yeah, so this project that I was doing was originally a PhD project, but it never finished because of COVID hit, so we evacuated. So he built this camera frame from PVC pipe and steel pipes. And then some parts were rusty, so I had to rebuild them. So I rebuilt like the camera attachment, so I could also like decide on the range of the cameras and the angle and so on. But yeah, it was also heavy enough to not need extra weights, but really annoying to dive with it.
And so how long did you leave it down?
2 hours, that's how long the camera battery lasted.
That's right.
Yeah.
So there's another one, really great talk and very interesting work. Thank you. Were you able to identify individual sharks? And if not, how did you account for the probability of replicate sharks in the model?
Yeah.
Oh, you just answered that. Why do
No.
you think the fresher sharks have moved from Monarch to Pinot Show?
That's what I just answered. Before it was bare, probably from dynamite fishing. We still see occurrences of dynamite fishing, but now it's recovered, probably thanks to COVID or just the movement of fishing grounds for the fishing ground.
I hope that satisfies. Okay.
Any questions from the audience?
Congrats for the work. You've said a lot, so well done. I wanted to know if you wanted people to just have one information while going out and keep one information from your thesis in mind, what would it be?
That we have to find new methods to collect data on sharks rather than just fisheries data, because the shark populations are drastically declining, especially in like this part of the world where there is no data. So then you have to be creative in finding new methods. Yeah.
Yeah, I agree with everybody. It was a great presentation. I was wondering, was it easy to identify the sex of the individuals through camera?
Mostly, yeah, because I don't know. Let's see. Like even if the visibility is quite poor, you see this like anal fin is like it's usually hidden behind the claspers.
Okay.
So like even if you just see the silhouette, you can usually determine it's still a female if that one is prominent. Yeah.
It was just to ask about your diving setup, because if you were down there for 2 hours, depending on what depth, what did you do?
No, I wasn't. So I did one dive where I deployed the camera. I left it down there for 2 hours, and while I was doing that, I was just trying to take ID picture, kind of like a side project, to build like a catalog of actually identifiable individuals. And then I had a surface interval for 1 hour, and then I went down, and then I took it up.
Yeah, that makes sense. I meant
Yeah.
with 8 tanks.
No, no. I get cold even though it's 30 degrees. It was on, yeah.
I was wondering, is that specific population of sharks within this island? Like, are there also populations?
I mean, they inhabit like the whole Pacific and Indian Ocean. They're very uncommon to see just because they're so pelagic and solitary and deep-lived species. Like when they tagged them, they went down to 250 meters. They see them a few times a year in Egypt, a few times a year in Maldives, but it's very sporadic. So this is a very unique site. But we do suspect they comprise a single population because we have been seeing some deformities that we suspect might be from genetic depression and inbreeding.
Okay. And like if you, is there someone who did like work in a different area? Or
No, I think there's no published studies where they incorporated stereo cameras in demographic modeling before. Yeah.
Yeah, I wanted to also talk about the methods that could potentially be used about tagging, but now you mentioned that there were sharks that had been tagged.
Yeah, no, the problem is the cost, really. They were financed by Shark Week to do some acoustic tags, and they were tagged for a few months, and then they saw that in general the sharks visited the seamount and the cleaning station 33% of the days at Liberty. But their tagging did not yield enough results to do an abundance estimation of the population.
And then two alternatives would be what's the visibility like, or how deep is the seamount actually? Would drone be an option, or would you never ever see the top of the seamount through drone imaging?
No, because there's corals and stuff. Even if you're on the surface, the seamount now Kemet is more shallow, so it's 12 meters. You could potentially see it. Not at that, I can barely identify it when it's right in front of me.
And using citizen science, is there other?
I'm thinking of some, because there are some sharks that are identical, they have very significant cuts, scars, curved dorsal, and by having actual dive tourism and the dive shops actually documenting every time they see them and how many sharks they see in general, we could do complete abundance estimation. So that's a potential project, definitely.
Yeah?
Yeah, mine was just on the individuality thing. I don't think it was covered. It was like, how did you deal with not being able to recognize all the shards?
Yeah, exactly. So when I first was going to do this project, I was like, I want to develop a method for identifying them individually, like photo identification. But my supervisor said he's been trying to do that since 2006. So what I did basically was, if I measured a shark of the same gender and the same measurement from the same deployment, I assumed it was the same individual. But if it was at a different deployment, I assumed it was a different individual, even though that's like flawed, but I had to make some like adjustment like that.
Amazing presentation.
Oh, thank you.
So you spoke like something about 3D because I'm interested in 3D.
Yeah.
Can you just quickly go over it?
I just know that it's the same technology that's used when you're making 3D stuff. So you have a minimum of 2 cameras at different angles from the object to create it 3D, and that's also the open source software that I used.
Okay.
People use it for 3D reconstruction.
Okay, which one is it again?
Stereomorph. It's an R package.
Okay.
And I mean, there are better softwares, but they're a lot more expensive. So I wanted to do a product where it's available for people to apply. And also, I didn't want to pay 3,000 Australian dollars. And that's also like you can buy frames like that, like steel made, but they're also super expensive. So I don't know why people are doing that when they can just build one. Yeah.